Nice.
All right, lovely people. Let's get started on these couple of days of stress-free activity, collaboration, learning together. I know some of you people will be working a bit on the side. That's fine. You follow what you follow, you get some ideas, you think about those freely, and then have a chat with the speakers. The speakers are sitting here on front, left to me, right to you, and they love to be approached with difficult questions. So if you have anything to ask about the topics they talk about or speak about, don't hesitate. Don't hesitate 1 second. Just go there and say, hey, I have a problem, and they'll fix it. It will be fixed. There will be no problems after that. I promise you, it's a personal guarantee. Well, no, that was too far. It's not a personal guarantee, but still, they'll try their best. So, if you look at, this is the IglooConf.fi website. The stream has started, has it, Tony? Yes, Tony goes thumbs up. Thank you, Tony. And welcome to all the people at the stream as well. Glad to have you here. So if somebody is at home or at work and can't attend, but they're interested in one specific topic or a speaker or whatnot, just tell them to go to IglooConf.fi. It's live streamed, and they can check it out there.
Indeed.
My name is Sakari Nahi. I'm an Azure MVP, Regional Director, and the CEO at Azure. And this here is Pasi Huuhka.
Yeah, I'm Pasi Huuhka, as Sakki already mentioned. I'm an Azure MVP also, and I've been doing DevOps stuff at Azure. But here I'm one of the organizers of Finland Azure User Group. And I'd also like to welcome you to our conference.
So if you have any issues with how things are organized or you're wondering about something, you can always approach Pasi here.
Yes.
He will answer all your questions in a very friendly manner. And then as a second step, you can also approach me. I will talk in a friendly manner, maybe not answer the questions. Was this my slide?
Yes.
Okay, cool. So, Scandic easy, Wi-Fi, it's open. You should all have electricity here, but you know we are a little bit low on the plugs, so you have to share every now and then. But if you need to take your laptop, just take it out and use the Wi-Fi here, so that works. On Finland Azure User Group, check out, put Meetup FAUG, F-A-U-G, in Google, and you'll find our community. We have over 2,000 members. During the past few years, we've been organizing these remote events that don't do that well for me personally, at least. So it's very nice to see you all live again. And we'll be starting on organizing these kind of events more again. If you have any hankering or interest in being a speaker or speaking or presenting in one of the events, just reach out to us and we'll set up a chance for you to do so.
Yeah. We kind of like to have new speakers coming up so our community can grow even larger than it is right now. Yeah, so our sponsors today, we have a bunch of them. Thanks to every one of them, but Go4 was the biggest one right now that we got first. They have been doing great Azure stuff for many years. Then we have Malo, who's a bit of a newer company, but you should take a look at their services also on the IglooConf site. You can find the links there also. Then we have Sql, Azure, and of course Microsoft, who of course do some Azure stuff on as well.
Basically, we couldn't do this without you guys, without the sponsors. They're in this room and they have a lot of stuff outside. Please talk to them, have a chat with them. These are great companies. And this year, just to let you people know, we are probably gonna like break even. So this is not a business. We are not making money with this thing. So we are pretty much breaking even. So without these guys, this would be a lot more stingy thing. Now we have a lot of things for you guys to do and say. On that front, here are the speakers. like I said, most of them are now sitting up front, and we will start with Rik, who will soon be introducing himself. So just like I said, if you feel like you want to say something, just approach them. They like to be approached.
Yeah, regarding the space, we are here at the stage, and then we have the coffee area here where we will have breakfast tomorrow and also snacks on both of the days in the evening, afternoon, more like that. Then we have the partners area, which is directly behind this wall here. You can find the sponsor stands there. Go talk to them, as Sakki mentioned. And in a couple of hours, we will have lunch, which is basically behind this wall here in the end of the alleyway there.
Thank you, Pasi. And now I would like to welcome on stage Roope from Microsoft. And he would like to say a few words because Microsoft is really making this possible with their generous donation to the cause.
Hello, hello. Thank you. Welcome all, and really nice to see you in person. Let's make most of this. So we have technical stuff on our booth. There's also socks, colors of spring and summer. So please go there and pick your color. There's lots of things.
Don't leave now.
Yeah. Wait, just a second. There's lots of happening in Microsoft at the moment, also in Finland. We have DCs coming up, etc. So visit our booth. There's people who can actually discuss about these things. And like Sakki mentioned, they are here also to solve problems. I told them this morning, so they couldn't escape anymore. So approach freely, ask difficult questions, and be amazed of the solutions they can provide. So let's enjoy this 2 days of in-person conference, and also people online enjoy. Thank you.
Thank you, Microsoft. So, like Roope said, if you have any questions on, for example, he's there. If you have any questions on licensing of Azure products, for example, or pricing, if you have issues with the cost of the cloud, please approach the Microsoft specialists. They'll be able to help you guys. At the booth, not here, Roope, So, now that I've said this piece, and I'm happy about it, I will stand behind those words. The program today is, these are welcome words. I do hope you feel welcome. This is a safe space. And then the next 2 bits are about the cloud from a more broad perspective. I'm assuming, I don't know, I haven't seen these guys' talks. Rik doesn't know, so it's going to be a good talk. Rik will start, followed by Magnus. Then we'll have a lunch. Then I'll do some drawing on board, like doodling and stuff. We're going to have a snack after that, because that will be a doozy. And then Andreas and Mark will come with hard-hitting core substance, after which we have a panel. Speakers, some of you will be in the panel, by the way, so that you know. The questions will be revealed later during the panel. And then later we'll have the evening event. We have 2 different evening events. So the official is at Azure, and I call that official because the speakers are coming there because they don't know how to orient here in Helsinki, so they kind of just follow me like a row of ducks. So that's kind of cool, it's official. And then Go4 is organizing another, so I don't know, maybe you can bar hop and go to both or whatever, but you are welcome in both. If you do decide to come to the Azure official, then here's a picture of how to get there.
Yeah. So basically, it's pretty easy. Just take the straight line, so trams 4, 10 or 2 to Lasipalatsi, and then walk a little bit to the Makkaratalo. And you should be there, hopefully. Call us or send a message if you can't find.
Yeah. I understood that both parties have food and drinks, so I don't think you can go wrong, really. I think you'll be happy and have fun. On the live stream, if you want to share some other link than the YouTube or iglooconf.fi, that kind of short link also works, just for you to know. I called that a short link, but now that I'm looking at it, it's not that short. there might be some issues with organizing this event. It's going to turn better. So, without any other things to say, we welcome you all. It's very lovely to see you, and let's have a fun few days and have relaxing chats. Thank you for coming and welcome.
Thanks.
And now I'll introduce Rik Hepworth. Welcome.
Thank you. You'll notice that he doesn't even take his laptop away, right? You know, he makes me unplug mine.
Yeah, I'm very sorry about that.
Can't get the organising of these events. You're 2 years out of practice, right?
Yeah, his laptop didn't work last time, so let's spend 5 minutes.
Hey, it's alive, I tell you. And it's even on the right screen. Result. Hello, good morning. Thank you for the introduction, Sakari. I cannot tell you how nice it is to be here. IglooConf was the last event that I did before the pandemic lockdown, and it's so nice that it's also the first one I'm doing after we're all allowed out to play again. So, for the next 60 minutes or so, I'm going to tell you a story about a real project and a real product, and the work that we did, have been doing, are doing to move it from on-prem to the cloud. As Sakari said, I am another Microsoft Regional Director. In fact, I think we've got 4 here, so yay. I'm also an MVP. I've been an MVP for quite a while for Azure, but I actually have a day job, and my day job is I'm Chief Consulting Officer at a company in the UK called Black Marble. So let's look at what we're going to talk about today. So I'm going to try and talk to you about what it is we're lifting and shifting and moving to the cloud, what the application is, what the customer wanted, what was driving the migration, how we thought we were going to do it, how we experimented and started to do it, and then what we actually did, and you know, sort of how far we've got, what the problems were, and hopefully try and give you some advice. You know, don't do that, it hurt, do that, it went really well. So I've basically split this presentation up into Rik's 5 stages of grief. Sorry, migration, anger, bargaining. And I talk to customers all the time, and I recommend they take the similar kind of approach because we've done it and we've proved that this works. So we're going to start with evaluation, looking at what you've got, understanding how it works on premises in your current environment, so you know enough about it to move it, but also enough about it to be able to compare what you're building to what you've got. Make sure it works, make sure it's running correctly. Then we're going to talk about translation, putting what you've got in the cloud unchanged as part of the sort of testing and development process even. Not just lift it and shift it and now it's going to work in the cloud on virtual machines. Friends don't let friends do IaaS. Once we've got it in the cloud though, that enables experimentation. Changing bits of it, see what happens. What if we put this on app services instead of a Windows server? What if we change our data backend? All of that kind of stuff. Modification, the actual process of doing the work to start swapping components out, upgrading, updating so we can run effectively in the cloud. And then finally, operation, where we've actually got to move this to be a running, living, breathing product that our customers are using. So let's start with evaluation. Shockingly, this is the bit that everybody thinks, yeah, we know our product. But actually, 9 times out of 10, they don't. And there's this overconfidence, he said, trying to pick a polite term. You think you know it, right? It's your favorite child. You built this application. It's been running, in our case, for 7 years. And you've been operating it, you've been supporting the customer. You think you've got a really good understanding of how it works and how it scales. And I'll tell you now, you probably don't, and you need to find out. So let's start with how we're going to do that. So the application that we've got is driven for the users via a mobile client. So they're using a UWP app, they're using an Android app. That application is secure, so we talk to ADFS to get an authentication token. Once we're signed in, we have a client API that the users are talking to. And then that client API is supported by a set of core services. Yes, I am the only person on the planet still using Service Bus for Windows Server. No, I did not ever manage to get Dan to give me an upgraded version of it, so unfortunately, that one's dead. I'm also the only person on the planet probably still using Redis for Windows. That's also dead. You're spotting a pattern here, right? Our database backend is SQL, but we're also using FileStream. We put binary files into this thing, so we've got a huge sort of data store with binary files there, as well as what actually turns out to be not a huge amount of data in the SQL DB itself. Service Bus is there because the client API is generating work. It drops messages onto Service Bus. Those messages are consumed by a portfolio of Windows services. So they pick up a message from Service Bus, they go and get data from the database, they go and talk to Redis, they stick more messages on the Service Bus. And then behind them, we've got some internal APIs. So those services can make calls to a suite of internal APIs to send data to and from other systems, for example, imports and exports, that kind of stuff. Which means, because we've got external systems involved in this, we have to talk to those external systems. Now, enter stage left BizTalk, that well-known, easy to move to the cloud product. The living, beating, thrumming heart of all of this, which is talking to all of our customers' external systems. And just to be a bit of a pain, those external systems, they're all on a secure network. We can only access them over a secure network. And then finally, we've got Sql Reporting Services, because we generate PDFs from this thing, which is another product that has no immediate cloud analog. But when we started this project 7 years ago or so, the customer said to us, we're not ready for cloud yet, but we will be. So we want you to think about that when you build the product. And I remember standing on stage at other events, telling people that this was a great way of doing it. Hey, you know, think about your app architecture. Think from the get-go how you might put it in the cloud, because it's going to make your life a lot easier. So part of this presentation, if you like, is marking our homework on how well we did. So we knew that we would probably end up in app services, right? So our website has always been built and packaged and deployed using web deploy. And I'm a DevOps guy, so I talk about things like parameters XML and applying config as part of the pipeline. The Windows services, when we built them, we decided we'd package them as a zip because that was the easiest way of getting onto the customer's systems, but also because a zip file means we can throw it into app services. And the team deliberately wrote those services so they can run through Service Host as a Windows service, but also run as a console app. And a console app will run as a web job in app services. So we thought about this. It's like, okay, there's our basic scaffolding is the website goes in app services as a website, and the services go in as web jobs. Job done, tick, right, there you go, cloud migration, yay. Our SQL databases, we do data projects. So we're building DAC packs. So our schema management, our database deployment is robust. And as you all know, a DAC pack can deploy into SQL Azure as well. Authentication, we used the ADAL libraries when we started, which supported both ADFS and Azure AD. So we just repoint, easy peasy. And we chose Service Bus for Windows Server because we knew that Service Bus was also in Azure. We didn't know that they would immediately discontinue it, so that's been entertaining. And again, Redis, if you want a cache, you normally pick Redis, right? We thought this is a good choice, it's going to have a long life. We didn't know that Microsoft would discontinue the Redis on Windows. Bless them. So our expected migration, if you like, has a, where are we now? Where do we think we're going to with that initial migration? And where do we want to go in the future as part of that sort of longer term project, if you like? So like I said, APIs, we'll put them into IIS. Largely unchanged, okay? But what we'll then do is we'll front them with APIM, because that's going to allow us to version those APIs and then crack them apart. And a lot of them, we can hopefully move the code and run it in Azure Functions. The services will start with web jobs. But again, we know we want to get rid of those web jobs. We want to move most of these to run on demand. So the plan is we'll translate those to Azure Functions. Redis, well, that's easy. We're going to use Azure Redis. We thought long and hard at this. We looked at the competition. It said Redis. We picked Redis. This one, however, this is a bit of a tricky one. SQL file stream does not exist in any of the cloud versions of SQL. Not in Azure SQL, not in Elastic Pools, not in managed instances. So we're going to have to start with a VM. But we want to run on SQL Azure. There's only one database using file stream. So the hope is that we should be able to move most of the workload fairly easily, and we will change the way the software works to get rid of file stream. And BizTalk. Oh, BizTalk. BizTalk will be a virtual machine for the shortest possible time, because by crikey, that's expensive to run. So the immediate work will start to try and break that apart, and we'll shift to using logic apps and functions. And then finally, reporting services. Well, actually, we want to get rid of that entirely. It generates PDFs. We've got other functionality in the product that generates Word docs, so we just want to replace that, and we'll move that into Azure Functions as well. So we've got a plan, right? We know where we are. We know where we're going. ADFS, we hope, will be straightforward. To begin with, we're going to stick to ADFS because the customer is still using its on-prem AD. We're authenticating users with that. But we will transition to Azure AD because they're now a big Office 365 user. So as part of this, we've identified some constraints, which I've been talking about as I've been going, and we know we're going to have to deal with those. But the biggest constraint often isn't necessarily us or the technology, it's the customer. Now, they're a great customer, but they can blow a bit hot and cold on this, you know. I mean, we started off, they wanted to be in the cloud really quickly. That was 7 years ago. This migration was being driven by a hardware refresh. So everything's end of life. We're running on Server 2012 R2 at the moment. We're running on SQL 2012, BizTalk 2013. All of these things need ratcheting forward. So there's a big push there. And the customers now really enthusiastically adopted Office 365 and is really starting to look at the whole SaaS offering. But this isn't just operated by us, it's operated by the customer teams. There's a bit of an anchor there because their internal teams don't have a great deal of cloud expertise. So we're going to have to bring them on the journey with us. They have security concerns and constraints. I mentioned that we can only talk to these external systems over their network. They're worried about how we're going to put stuff in the cloud, how we're going to secure things. And timescales might be fun because we've got a hardware refresh coming. So we need to be able to put stuff in the cloud quite quickly if we're going to make this work. Otherwise, we're back on-prem again. So, remember at the start I said evaluation, you need to know and understand how your product works and what it does. And when you build these things, you put logging in, right? What you don't necessarily put in is telemetry, and there is a difference. Logging tells me what happened in that beautiful way that you developers do. It's like reading a story. An error occurred, and this happened at this time with all of this information. And there's like 14 paragraphs of information in there. And it's brilliant, but it doesn't actually really tell me anything meaningful about what's happening when that error occurred. How much memory are we using? How much CPU are we using? All of that is telemetry. Now, we didn't have telemetry in this product when we built it. We've got logging, we're using nlog. But if we're going to move it to the cloud, we need to be able to look at what's running and work out how much memory it uses and look at how many requests we're getting in, because we've got to right-size the cloud services, right? So the first thing we did, and the first thing you should do, is we plugged in App Insights. And that is a remarkably easy process. 3 stages. The first is, we just installed the App Insights agent on all of our servers. And the second we did that, it plugged into IIS, and out of my website came all this beautiful telemetry. I was getting performance metrics on how much memory the server was using, on how much memory my website was using, how much CPU it was using, how many requests a second are coming in, what those requests are, whether they work, whether they fail, what the dependencies are, because it could see my calls to SQL. With a single line config change, now I could see the SQL queries that were going out. Brilliant. Stage 2 was we plugged our existing logging into App Insights. Not because I wanted to continue using logging, but we discovered really quickly that we got all this rich data about what's happening in App Insights, and all of the logging is in a SQL database. So they're not in the same place. So we wired nlog into App Insights, which was a really quick process. We create a telemetry provider inside our code and follow a couple of really nice readmes that Microsoft have got, and immediately we get a new output channel for nlog, which squirts all of that logging into App Insights. And we went, yay, and turned all of the logging up to its highest level, and then went, oh, crap, how much data, how expensive? Let's turn that back down again. But it allowed me to do certain things. It allowed me to look at our old logging error messages and then grab the telemetry from the same point in time and start asking and answering questions. And that proved so useful that we actually started to add this into the code. So we started the telemetry journey a couple of years ago, perhaps even more, to be fair. Now we've actually put custom events and, importantly, custom dependencies in. Custom dependencies have been the single most useful thing, I think, that we put in. And we get that wonderful app map there. So all those external systems that we talk to are now defined as dependencies. So I can see how many calls I make and what the failure rate is. Because some of these systems that we talk to are quite old. I need to know what normal looks like, because if I don't know what normal is, how do I know whether my cloud application's working? And we get to be able to run really cool custo queries, where all of this stuff is in there. We found a memory leak with this stuff, where I started doing crazy scatter plots, where I'd got my server memory plotted against what requests were coming in, and the y-axis was how long the requests took. So I could see which requests were coming in as the memory usage was climbing, which allowed us to then dig in and say, right, okay, we think it's that request. Let's now look at the request itself, and we can see the dependencies, and we can see where we're suddenly taking a long time, and then we could look at code. That kind of diagnostics is impossible if you've just got logging. So now we've got a good idea of what we've got and how it runs. Now we need to think about how we get it into the cloud. Now we've got a plan, okay, so we could go dark, change all the code, update everything, and then put it in Azure and see whether it works. And that's okay, but it's an approach that personally I hate. Because you don't get to see how the product operates in the cloud unchanged to begin with. Again, if we don't know what normal looks like, how do we know whether we're making a difference and doing things right or not? So the first thing I always say is let's get it into the cloud unchanged. And this allows you to build some things that are going to be useful moving forwards. So we build infrastructure as code to deploy things. We have to tackle a bunch of technical challenges to get this thing running in the cloud, but the solutions to those will help us in the long term. We're going to have to look at things like virtual networks. We're going to have to look at how we deal with service bus, because that's actually got to be swapped out completely. So this also allows us to bring the customer on the journey, because we can show them that the skills that they've currently got will translate to the cloud, because they can see us doing this with things they know and understand, because we're going to start with virtual machines and we're going to start with virtual networks, and then we're going to evolve. So we start with this. It's a virtual network. It's a secure bubble. I know I need to present services to the outside world, so immediately I am going to have to start adding in Azure services just to publish this out unchanged. So we add front door and WAF. Because we're in a bubble, private link and private endpoints enter stage left, so I can connect into that bubble. I know that Service Bus is dead, so I'm not even going to try putting that on VMs in Azure. We're going to connect Azure Service Bus. But because of the security requirement, I immediately need to use Service Bus Premium and plug it in with a private endpoint. Exactly the same with Redis. And that involves a bit of scaffolding coming along for the ride as well, with some private DNS zones to make it all work. And we built all of that with Bicep, or ARM templates, so we could deploy. And it was great. So the good news is, you know it, you understand it, you love it, you can do it really quickly, right? To build all of that, which is quite a big diagram, right? That took me a day. I built all the Bicep in a day. I spent another couple of days doing a bit of debugging, a bit of tweaking, but it was an incredibly quick process. But it also exposed some of the pain we were going to hit, because front door's great, but there's a lot of layers between it and my application. Debugging that is a right pain, as it turns out. So we learned a lot in the process about looking at Azure's own telemetry. So in addition to our app insights, we realized that we need to plug all the diagnostics from the services we're now looking at using into the same app insights, the same log analytics. So we get all of that telemetry along for the ride, and then we can start to look. So I can see the inbound request to front door, and I can see whether it's being accepted or rejected by the WAF. So one of the biggest problems I had, we use SignalR. It turns out that the way we do our request headers on the SignalR requests to the WAF in front door looks a lot like a SQL injection attack. It's a device ID, for God's sake. How does it look like a SQL injection attack? But because I'd got the telemetry from front door, I could do a search, and I could see all the requests, and I could filter by the ones that were blocked, and I could see the rule that was being matched, and I could go and read the rule, and we could make changes to our code so we no longer got blocked. It is really important, though, all that knowledge you've got about how you run your application, you've got to bring it along. You're now configuring VMs in Azure. You need to know and understand how you configure and run those VMs on-prem so you can make sure that everything matches. So hopefully you've already got config as code, right? Because we all do this properly on-prem, yeah? So we can just bring that config as code across. We do, for our Black Marble internal dev environments, all of this is configured using desired state config. But our customer didn't use that. So interestingly, I deliberately didn't use config as code for this environment because I wanted to build it how they build it and follow their instructions. Again, so I'm comparing like for like. Now we've got this in the cloud, now we can go on to the cool and fun and interesting bit. Experimentation. Slight tangent. did a bunch of work for a big engineering company in the UK. And it was a DevOps engagement. And it taught me a lot. And one of the things it taught me was that giving developers the freedom to experiment and making it easy to do will really help if you are trying to modify and improve a product. So we pretty much followed the same plan with them. We built some infrastructure as code so they could deploy VMs to the cloud for this really big mission critical system. But once they'd got the ARM templates to do that, they'd create a branch in the code and go, what happens if we just stick a website in here, an Azure website instead, and just deploy things using the same pipeline? Does it work? Oh, it does. Oh, right, okay. Now can we modify the code with that? And they would do like sort of hackathon-driven Spike projects where they just would pick a component of that product and just see what they could do. And because we'd built all that automation, because we built all of that infrastructure as code, it was easy for them to modify discrete parts of the app, chuck it into the cloud, and see what happened. And they got a really quick pace of change going by doing that. And they migrated the app to be running on Azure PaaS services pretty quickly. Like I say, I learned a lot, and I watched and went, that's a great idea. You know what? I'm going to take that idea, and I'm going to tell everybody else it was my idea. So, we are going to make sure that we have a repeatable, reliable process to build that bubble, and then we're going to tinker with it. And because we've taken the time to instrument everything, what we do when we tinker will be meaningful, and we'll be able to see how it works. And we'll combine that with the automated tests that we already have for the product, and we'll use those to poke and prod and play with it in a managed, repeatable way to see what happens as we change things. Brilliant, right? So we end up with this. I modified the bicep. I stuck in app services, which immediately failed to work. So, doing this showed us a few things. Showed us that we write to areas of the file system that it turns out we need to sort permissions out on. Showed us that authentication is fine user to system, but we've got service to service authentication that maybe we hadn't really thought about so much. So, over a bit of time, I was working in a branch of the code I was trying to deploy. I tried to deploy my SQL databases. When they failed, I started hacking around with the DAC packs, just to see what I would need to do and what I would lose to get things to deploy. And we answered our fundamental questions. Can we deploy to Azure Sql? No. So the plan was great. 7 years ago, we said, right, we'll use DAC packs, because I can take the same DAC pack and I can deploy it to Azure Sql. And you could 7 years ago. You can't anymore. SQL Server is a completely different deployment target in your data project. So you have to switch. You can't just move the same artifacts around like we hoped. Ironically, if I wanted to use managed instances with the latest versions of the data projects, there is now a SQL Server and SQL managed instance, and that is translatable. But that's not really where I want to land. So we are going to have to branch the code and do some work on changing the DAC packs. We know that file stream is going to be a problem. I had high hopes. You know when you get excited? I read the other day, ooh, SQL Server 2022 will use Azure AD for authentication. Huh, okay, that's interesting. Maybe I can sort of plug this in somehow. Maybe this will help me with how I'm going to sort out file stream. Because when I put app services in, I changed the connection strings. That's all I had to do to make app services talk to my SQL DB. Change the connection strings, and I have a local user on my SQL DB, and I can talk to it. Brilliant. So I tried an experiment where I put the SQL server in with no domain controller. Just ran my SQL accounts. Turns out file stream doesn't work if you just use SQL auth. Didn't know that. So I thought, maybe I can use Azure AD and use Azure AD accounts. No, that doesn't work either. So you read the documentation, you get excited, then you try it, and it doesn't always work. But that's what the experimentation is for, right? And the other thing that we realized is our DAC packs create SQL agent jobs. There is no SQL agent in Azure Sql. We could use managed instances that has SQL agents, but actually when we look at what those jobs are, because we did, they're the kind of things that we can replace with timer triggered functions, that kind of stuff. So question number 2 then, does the API work in app services? So nearly. 2 things tripped us up. One, so when we upload binary files to the system from the client, the website drops them onto disk first. That's fine, thinks Rik. I'll just tell it a path on app services, and it'll put them on app services. And it didn't. It completely failed to write to app services, no matter what path I told it to, no matter where I put the folder. So that's why on that diagram a moment ago, Azure Storage enters the picture, because I created an Azure file share, and I had to map the Azure file share onto app services, so it had a path that it could write to. I've already mentioned in the SQL slide, we discovered that we had to use SQL authentication for talking to the DBs. We kind of expected that. But then we discovered if we're using SQL auth to talk to the DBs, we can't make file stream work. So sort of 70% of the user functionality actually worked with virtually no changes, and maybe an hour or 2 of me tinkering. But there's still dev work to be done. And then the mighty web jobs. So this one, I've spent many years going, hey, we've got this one absolutely in the bag, chaps. We know that these services will run because I can just double-click them, right, in Windows Explorer, and it fires up as a console app. I can, in a command prompt or a PowerShell, I can type the command, and it fires up as a console app. This one is going to be easy. So I took the zip file, I uploaded it using Kudu, I told it to start, and it went, computer says no. It started, it stopped, it started, it stopped, it started, it stopped. It's not working. As it turns out, I employ clever people. As it turns out, they're too damned clever. The reason things didn't work is because the very first thing the service did was query the .NET environment. And it said, am I user interactive? And if the .NET environment said, yes, you are, we started as a console app. And Windows answers yes to the question, am I user interactive, if you double-click something in Windows Explorer or if you run it in a console. The thing that's hosting our web jobs just says, no, you're not user interactive, which means we go, ha-ha, we're a Windows service, and fail. If we just put a command switch on the thing, I could have done service.exe/console mode and it would have been fine, but no, we had to be clever. As it turns out, that is a really quick and easy change to make. And once we've made that change, everything works. And all of our services fire into life. They talk to Service Bus with a connection string. We know we can talk to SQL because we can talk with a connection string. And that was great because that was the bit that I was most worried that if we couldn't make them work, there's a whole lot of back-end automation. So as you can probably guess now we're starting to move into the right. We've identified the things that don't work. We've identified the new services that we need to plug in. We've started to figure out what it is we need to do to change the application to run effectively in the cloud. So now we're into modification. Now we actually start formally modifying and changing things. And then you realize that once you've started this marble rolling down the hill, it's not a marble, it's a snowball, and it's getting bigger, and things are happening that you weren't necessarily expecting. So the first thing we did was we updated all our dependencies. By crikey, that was interesting. We updated the Redis NuGet packages and suddenly couldn't talk to on-prem Redis. Because we thought, well, that should be, backwards compat, right? But no, the Windows version of Redis we were using was so old, it didn't do TLS apart from anything else. So some unexpected things happened. Good job we're working in a branch, right? Good job we keep backwards testing with all of this because we need to be able to continue to deploy on-prem until we're ready. We also started looking at whether we could replace Signal R, which we're running inside our application, with the Azure service, because that might allow us to simplify some of our code. It might allow us to get away from having to host it. It might allow us to interact a bit more easily with Front Door. And then the two biggest things that we've been doing, the project itself was, it's actually a couple of Windows solutions, but they sort of share projects. So everything was solutions and projects, and everything got built at once. So we'd got a shared component architecture, but we had one big monolithic build. And the most useful investment in time, it turns out, of everything we did was saying, you know what, we're going to move from monolithic build to NuGet packages. So we took all of those projects out of the main solution. In fact, we actually pulled the code into other repos, and we built build pipelines that would compile all of those, and we built our own NuGet packages. Now, that gave us some tangible benefits on its own for the project, because now we're not building as much, so the build time went down significantly. It also means now that we can rev those individual components at different paces, and it means we've removed some risk, because a change in one thing no longer ripples through and impacts everything immediately. So you can start to do engineering change control. We will rev this package over here, but the engineers of the main solution will choose at what point they are comfortable updating to the latest version of the NuGet package. And because we're in NuGet, things like Azure Functions and cloud services become easier because they know and they understand NuGet. And the way we package things means that we can have just the stuff we need for the component for which we need it to then deploy to the cloud. The other thing we know we need to do, and I'll be honest, we are kind of shy about this one, is we are a .NET framework project. We're running now .NET 4.8. We know we're going to need to move to .NET 6. But that in itself is going to be a challenge, because we have an Android app which is written in Xamarin, and we have an awful lot of shared components which are written in .NET Standard, .NET Standard 2. And now we've got a bit of a sliding block puzzle, which is going to be interesting to tackle, because we can't move from .NET Standard 2 to 2.1 without breaking the Android stuff. But if we want to move to .NET 6, we need to move to 2.1. So again, we're trying to look at how we can continue to break the application down and separate things out and try and remove those tight couplings so we can manage and change better. So on to operation, running it in the cloud. This one is where I see most of my customers get caught out, partly because of the skills and experience of the people they've got, and partly because of the emotional baggage, so we say, of how we've always dealt with software which we write and run on-prem, which has a relatively infrequent update cycle. So the first part of this, to a very large extent, is give everybody a hug. A lot of resistance to cloud you will find is through fear. Fear that my skills are not going to be useful anymore. Fear that I've got this huge hill to climb, right, of skills and knowledge of how we run stuff in the cloud. But actually, cloud isn't that scary, particularly in the scenario that we're talking about for this particular product. Because in order to meet the security requirements, I have to run in a virtual network, which means networking. Networking, that things devs hate and don't understand. And IT pros go, ooh, all right then. So, first of all, I've got to get my developers on board and I've got to teach them. But secondly, I can bring all the IT pros that have been operating this product for 7 years in, and I can get them, actually, ironically, to do the skills transfer to the people who need to know stuff, whilst at the same time proving to those IT pros, proving to the customer who's not used to managing and running cloud that actually it's not scary and it will work, and all of those old skills are still valid and valuable. And the amount of stuff you've got to learn is not that horrific. But if you're going to do this successfully, you've got to do it properly. I always joke that if you want to adopt DevOps in an organization, it is not necessary to adopt cloud. But if you're going to adopt cloud in your organization, it is necessary to adopt DevOps. Because the principles of DevOps that push towards better communication, better automation, shifting everything left, will help you immeasurably as you migrate stuff. Because we want this reliable, repeatable process, right? Because we're literally rebuilding the plane while we're in flight. So I want to make sure that at least deployment and operation is something that I know what's happening and I know what's going on. But you also need to teach people not to panic, because cloud can be cruel, and you can deploy stuff, and it can be a complete black hole until you realize which buttons to turn on to get the telemetry out, to see some of the diagnostics. There's an awful lot of, oh my God, what's going on? How do we find out at the start? So you need to help people not to panic. You need to help people learn the diagnostic skills. You've got to help people learn things like App Insights and how to write Kusto queries and all that kind of stuff. It will really help you. So, interestingly, I sort of built this as a story with that, hey, you know, we've got this really exciting thing, we've got this product, we're going to move it to the cloud, it's going to be great. This entire session started a year ago, I think, maybe 2. Many moons ago at my first IglooConf, Sakari created this WhatsApp channel, right, so the speakers could talk. And that WhatsApp channel has remained, because we're all friends. So if I get a problem, I post in that WhatsApp channel. And I was posting questions because I was trying to figure out issues with front door. And somebody said, hey, Rik, that'd make a really interesting conference session. And I went, you know what? It would. 2 years later, we get to the point where I'm actually going to try and deliver this. And we're nearing the point, finally, after customer moved the goalpost, where we should be running in production in the cloud, except we're not. Which sort of deflates the happy ending, right? I'm going to talk to you about moving an app to the cloud, except we're not going to move it to the cloud. The customer decided they didn't want to move to the cloud in the end. They looked at it and they just weren't that happy that they were going to be able to operate it. But, interestingly, they did decide that there were benefits in the cloud, and they've accepted that we're on a journey. So all the work I did was still useful. All the work we did in changing things is still actually being deployed because we are running hybrid. We are now using Service Bus in Azure. We are now using Redis in Azure. We're running App Insights telemetry live on the product. We're looking at putting Azure Storage in. We're looking at pulling in more cloud services because it will help us increase the pace of change. And the customer knows that they're on a journey. They've just taken the foot off the accelerator a little bit. And that's okay. And as it turns out, for this session, it's a good learning, right? There is nothing wrong with saying, actually, we've decided we're not going to rush into the cloud. All of the stuff I've been talking about for the past half an hour, 40 minutes is still perfectly valid. All of those techniques of trying and testing, all of the skills you will learn can only ever be useful, even if it takes longer to get where you thought you were going. And that's fine. So I said we learned a bunch of stuff. The first thing I learned is that actually, thank God, I was right. All of that time I've been banging on about, if you are building a new application now for your customers that's going to run on-prem, architect it with cloud in mind, because the chances are it is going to move to the cloud, just not right now. It turns out that is really good advice. Building our application as a connected set of components backed by service bus, with separate caching, separate data tiers, all of that, meant that actually it was really straightforward in terms of how we would plan our cloud migration. And it was also good for helping us identify clearly what work was going to be needed and what was more important than others to be able to get us into the cloud. But I was overconfident, because the trouble is, I always forget that cloud is a moving vehicle and it's going quite quick. And you might think you're in the right place at the start, but then it turns out that the cloud's over here. And the things you thought you were going to use have changed. And actually, that is one of the most important things to think about when you move to the cloud. Cloud is for life, not for Christmas. When you move your app to the cloud, it is unlike an on-prem migration. On-prem's easy, right? SQL 2012 is defunct. We are going to move to SQL 2016. We will do the necessary work and upgrades to update our components. And then we can be fairly confident that the customer is going to run that until its last dying breath. The cloud, when our app is in the cloud, it's like having a puppy. You've got to pay attention. You've got to keep looking at the cloud and look at how it is changing and how that is continually impacting your product. Just look at Azure Functions as an example. We're now on version 4 of the runtime, I think. Because every time somebody brings out a new version of .NET, they have to stick a new runtime version on. And .NET itself is no longer this never-ending long Microsoft stream of support. It's got like a 2-year life cycle. So now we have tasks that we never used to, where we have to have people in our team paying attention to what's changing and what's coming and what the support roadmaps are and all of that. Otherwise, you'll find yourself in a situation where stuff starts to degrade. And now you're trying to run to catch up. Now you've got development effort that you weren't prepared for, you weren't expecting, you hadn't planned, and that is a problem. And if you take one thing away from this session, it's that you should all go away right now and wire some kind of telemetry service into your application if you do not have it. Logging is great, but it tells you what happened, and it doesn't give you the full picture of what was going on at the time. I don't really care what telemetry provider you use. Pick one, instrument the code, because it doesn't take very long to do, and start looking at that telemetry, because actually it'll help you support the application running in production even on-prem. And it's the single biggest change you can make and the single biggest benefit you can give to everybody. And then after telemetry, the team is the second most important piece of advice. Making sure people are comfortable with the changes that are coming, making sure you explain to people that all of those skills that they've built up over 30 years of working. I'm grey, I've been around for a while. But I started with IPX networks and NetWare and all that kind of stuff. But a lot of the stuff I used to do is still relevant now. The concepts haven't changed. It's just somebody keeps scratching the paint off and changing the color. You know, there's so much stuff in the cloud that demands the skills from the past. So you are not obsolete. You know, there is genuine value in old timers like me because we can say, hang on a minute, yeah, firewalls and security and trying to analyze packet flow and figure out what's going on with Wireshark and proxies and all that kind of stuff. That's a useful skill. And you tend to find that actually that's more of an IT pro skill than dev skill, which means we can share and we can teach and we can help each other. And once again, I've come to, you know, I said I wasn't going to rant in this session and I wasn't going to preach, and I've just sort of stood here and go, yeah, all hail the Church of the Great Cloud Migration. I'm hoping that over the past sort of 50 minutes or so, I've given you a bit of insight, a good picture of what we did. And I am hoping that for the next 10 minutes, you're going to regale me with interesting and exciting questions. So I will say thank you very much for listening. Thank you very much, Sak, for having me. Yes, sir.
I can start with that question. So just to make it clear to everyone, in the beginning you had the journey, the think of where the application is now and where do you move first in the cloud, and then the long move into what's going to be the modernization approach. So it sounded to me like none of your guesses in the beginning were entirely correct. That you had to work on all of the aspects that you thought might work immediately.
Yes. So
I just wanted to hear you say yes.
they always say repeat the question, right? The question was a simple one. Sak said, are you going to admit that you were wrong to begin with? Yes, I was completely wrong to begin with. Actually, that's an important thing to get across. Thank you. It's okay to be wrong. You know, because cloud is a fast-moving thing, but at least we tried. And as it turns out, because we tried, whilst we missed the target, we didn't miss by much. So I didn't hit Sak, but you know, Magnus is lying in a pool of blood now. So I was in the right area. Left a bit, right a bit, fire. We did spend a lot of time when we first architected the product looking at what was best practice of the time and what were the components at the time that we knew could run in the cloud. And we adopted deliberately the technologies we did because we thought they would have a good lifespan. We thought that it would reduce our effort. And yeah, we weren't right, correct, but we were close. And had we not done that, it would have been harder. And we would have been in that horrible situation of put it in containers and move it that way.
I want to continue, and that's the point I want to understand, that none of us will be right when we are doing something complex. The first time, statistically will be a failure. The key is to let everybody around you understand, including the customer, that this is not the truth, that we will get there, but it will take some time. I don't know, it took a couple of years for you, maybe some other team might have been doing it faster, I don't know.
Again, to repeat the question, Sak just said, if the customer had got Azure to do it, it would have gone right first time. Is that right, Sak? No, he's right, though. I mean, what he actually said was, look, even if you hire an expert, and the expert knows what he's doing, and I like to think I know what I'm doing, they can still be off the mark, but they will point you in the right direction, which is good and is useful and is helpful. Magnus, you get your hand up.
The whole scenario here with the you win some or you learn some, we kind of fall into the learn some category here.
Yeah.
Why in the end, if you could elaborate just a little bit, why in the end did the customer back off, decide to back off? And also, which other learnings, like with automation or infrastructure as code and stuff, did you actually pick up and give to the customer that they are now using, despite not going to Azure with this thing?
Okay, so what Magnus just asked for the audience at home was, of the learnings, what did we learn that has actually sort of made it into production, if you like, has helped the customer? And could I elaborate a bit on why the customer decided not to move in the end? So the simple answer to the first one was actually, it turns out they had too much on. The teams that we work with at this customer are great. They're really, really talented people, but they only have so much bandwidth. And over the past couple of years, they've had lots and lots of projects. We thought that because there was an infrastructure replacement project going on, that this was the perfect time. And by moving to the cloud, we would help them because we'd take that off their plate. As it turns out, the infrastructure replacement has to happen because a significant portion of their estate cannot be moved to the cloud. So, in truth, we weren't taking something off their plate. We were putting something completely new and unknown and potentially scary onto their plate, and we hadn't realized that. And it did take a while for the customer to actually put their hand up and go, actually, you know what? We've changed our mind. We think this is going to be the wrong choice. But all the work that we did, I said there were some benefits, right? All the work we did in componentizing the product, ready to move it to the cloud, that has massively improved the product on-prem. Our build times are quicker. Our components change at different paces. Our overall quality is up. The amount of unit tests is up because, you know, if we're in the code and moving stuff around, we'll improve it. We've got a much better picture because of that telemetry of how our app runs in production. And because we've added certain components in that have to run in the cloud, we have started the customer on a journey, and they've been learning about how to solve problems like how do we give secure access to the services that are running in Azure right now, right? So Service Bus, Redis, App Insights are in Azure now because they have to be. Because no matter how much I begged, Clemens would not let me have Service Bus on-prem. That's really helped them. And that infrastructure as code that I built, that's what we use to deploy the components that are in the cloud. And that means the customer's also being exposed to those technologies and they're learning them and now they're on the journey with us. And actually I think that has been invaluable. We've learned as a customer-supplier pair to be better at communication. You know that whole you sort of notice when your friends are struggling? We've learned to understand more and pick up when they are under pressure and under load, and you know, we don't hassle them as much. So I think everybody got a lot out of the project. And like I say, we are still on a journey. So even though we're not in the cloud now, we are going to move more and more stuff to the cloud as their workload drops and their confidence increases. Any questions from not speakers? And not Sack, because he's picking on me. Yes, sir.
Yeah, on the little bit more technical side, how would you approach, or how will you approach now the selection between Azure Control and application gateway? You mentioned that both.
So the question is, how will I approach the selection and choice between front door and app gateway? The answer to that's easy. I never considered app gateway. And you're going to go, why? Why, Rik, did you not consider app gateway? Apart from the fact I just think front door's easier, I mean, actually, fundamentally, it kind of comes down to that, right? Front door is just easier. It's a global service, I don't need to worry about it. I don't have to think about how I plumb it into my virtual network, how I'm gonna, yes, I've got to configure it, but it's there. You know, it's a ring 0 service, it's always gonna be there. Putting a private link service into the virtual network so that it can reach in and talk to the stuff in the bubble was incredibly simple. And I don't have to worry about you know, app gateway deploying a bunch of VMs that I need to put somewhere, and is it in my VNet or a different VNet, and is that peered, and have I got enough IP addresses on the sub? All of that kind of stuff. It's just easier. But also, and this is worth calling out, because I've done exactly the same for Black Marble, we have one front door, and it's there. And we can plug other services into that front door because that's what it's designed to do. So, you know, Black Marble has our corporate front door, and all of our internal services are plugged into that. Whereas App Gateway is more of a, if I've got one application, I've got one app gateway and that app's infrastructure, right? And my other application has another app gateway. And now I've got two, and the things are breeding, and I've got to look after them. And so, yeah, frankly, front door for me is a really easy choice. Okay, Sak, now you can ask the question.
Well, no, I was just thinking if in your opinion, when your customer is postponing the transition to cloud because of the other workloads they have, are they prioritizing correctly?
Ooh, that's an interesting question. Do I think my customer is prioritizing correctly because they've pushed back their cloud adoption?
This is streamed and will be in YouTube, so if it's an existing customer, maybe.
So, I think it's horse trading, right? Them choosing not to move this application to the cloud slows down the roadmap for this application. It will stop us doing some of the updates and new features that we had on our roadmap as quickly as we could. And because of what this application is used for, that does have an impact. But the worst thing you can do as an organization is try to push ahead with a project which is that final straw. It's the thing that you can't keep all the balls in the air at the time. And suddenly, this is the ball that is the most difficult shape. It's the different weight to everything else because it's new to them. So I think it was the right choice for them because they looked at it very sensibly in terms of value and risk. And actually, those two words are the most important things when you're looking at any technology project and any cloud migration. It's not about the technology, right? The technology is not actually difficult. If I need my devs to learn Go, they'll go and learn Go. If I need to skill up on new components, I can do that. But we should not even be considering the project unless it brings value to the customer and reduces their risk. If it's the opposite, you shouldn't even start. And in truth, the whole of the approach that I spent nearly an hour talking about comes down to those things. We tried to minimize the risk by doing small things, by making sure we understood how the application worked and put it in the cloud. And we tried to maximize value by making small changes that gave tangible benefits. People think I'd sort of pump primed you with those questions, apart from the ones where I admit that I'm not as good as you.
You're better. All right. Thank you, Rik.
Thank you.
Now we're going to have a 15-minute break, and 10:30, it will be Magnus telling us how to pump up the value and lessen the risk with Azure, like Rik just primed. See you in 15. All right, guys, it's past. Welcome back to the room. I hope you all got some coffee and stuff. And we will continue after Rik's magnificent and remarkable start to the day with a broad theme topic. I asked some questions around and people seem to like it, Rik. Thank you. We'll continue on I'm going to guess from the name of the title that it will be a pretty broad view on what's up with Azure. And we'll have a repeat presenter present. Magnus Mårtensson, welcome.
Thank you. Thank you very much. And I cannot tell you how nice it is to be on a stage again. For someone like me to be up here, it's brilliant. And the reason I have my phone, does anybody terribly object to me to doing a crowd selfie? Everybody okay? All right, let's do it. That's brilliant, thank you. One for the memories, to be back on a stage, 2019, traveling all over the world, and then 2020 was a flat line for so many of us. But now it's to be back is bloody brilliant, actually. And I'm thankful to be here. Thankful specifically also to these people. Very thankful to them as well for doing this. How to begin? I think we begin with a story. To level set, to figure out where we are and see where the challenges might be. So this is the story about a company called Acme. It's a very successful manufacturing company. In fact, they're Finnish, as you can clearly tell from the name there. So they're actually from here in Helsinki. You should know them because, as it turns out, they manufacture caps for Mintu bottles and also all of the merchandise. So you can imagine how successful this company is. Like, obviously, they need to go to the cloud, right? So that's what they're doing. Getting ready to go to the cloud and getting out there with their products, with their all of their software and stuff. Yeah. So the challenges on the road to the cloud quickly become apparent to them. That there are different challenges and difficult things that they end up with. So they start having these problems, becoming really frustrated to find the financial control. You know, how much does it cost, right? Before they knew, on-premise with their IT, that was a budget post every year, right? So X millions for IT. And now in the cloud, the IT manager comes and asks the engineers, you know, what's it going to cost in the cloud? And they go, it depends, and we'll see. It's not the same model anymore. And also compliance, right? They start deploying to the cloud and they realize that compliance is important, but they can't really get a handle on it. It used to be something that they could control, and now in the cloud they feel they don't have the foothold really. Also security, they're struggling with that. They can't find out how to really get things locked down and the right people authenticated, and what about those consultants and how do we get them in, and you know, how should we handle this? So it's a journey, they're on the journey, they're going there, and they feel that there are new holes appearing and they're deep, and they keep getting deeper. When you're in a hole, stop digging. But it seems like they're never going to get out of this, and clearly something is not working for them. Now, I work as a consultant, and I'm sure that many of you as well in here do. I think you recognize this. I don't know if I've met even one company that really does all the things in the cloud really well. Interestingly, everybody's doing it, but no one is really perfect. And so we need to figure out how to proceed. We need to identify the real problem areas and strategically start thinking about what should we be doing now. I'm Magnus, again, hello. I work for a company called Devo Team, and now, full disclosure, right? The things that I talk about today are things that I'm selling, you know, every day of the week, right? So I'm talking about the work that I'm passionate about. the experiences I have had here. So this is by no means a sales pitch, right? So everything that I say about potentially, maybe sometimes I might name drop a product or something that we do, you could buy the same thing from any other vendor as well. So I think it's fair to do that. I'm not here to sell you anything at all. I do have benefit of a bit of perspective with the cloud. As it turns out, I was the first person to become an Azure MVP in the Nordic countries. So I've now 11 years running for Azure MVP. So with that perspective in mind, the cloud is quite different and interesting now compared to what it was when it started out. Started out with a handful of services, right? And now it's so many that no one can count them. And the same with the Azure data centers, in fact. They started out to be countable. You know, we counted them. Oh, there's 12 of them now. There's 46 of them now. But now nobody knows how many there are and in which countries anymore. It's impossible to keep track. So it's quite a different beast. And with this beast, I see that people are struggling. So in this talk, I promised you gold, right? It's in the title even. So it's fair to ask the question from the benches now, where is the moolah? You know, where are we going? I don't know how long this talk is. This is the first time I'm giving it. So it might be that we run out of time before I run out of slides, and that's fair. But what I will do is I will give away the end and the beginning, and then we'll sort of work backwards from there. So at least you know you have the takeaways, and then we can just talk for the remainder of the time that we have together. So the biggest areas of problem, you know, if we zoom out, that I see everyone is struggling with. These are the big three, and there's one more, operations. These are maybe the big four then, that everyone have trouble with. And they need to balance all of these things, right? So can you have everything being very secure and cheap at the same time? Maybe that's not possible, right? Well, it's one of those, you know, you have three options, you can only have two of them at the same time. It's kind of like that with this. So I found this lovely report from a company called Flexera that I was trying to find something to back my story, and I actually came across this report just as it happened. And this one is, I have a few of these graphs along to sort of carry the message in this presentation. If you look at this is where are we spending time? What are our initiatives? Across all kinds of organizations going to the cloud, where are we spending our time? What is it that we need to focus on or will be focusing on according to our plan? Migrating more stuff to the cloud and moving from on-premises software maybe into a SaaS solution, those are brilliant. That's, you know, the first one, migrating more workloads to the cloud, that's kind of my bread and butter, so yay. And Rik's as well, you know, according to his presentation, right? This is what makes our money, so that's brilliant. But if you can get away with it, moving to a SaaS solution is probably your strategically, you know, your smartest thing you could ever do. For example, a canonical simple example is rarely would you migrate your Exchange server VMs to the cloud and run Exchange in the cloud, right? That would probably not be the case. You might consider moving to Office 365 instead, right? So that's just one example. Where you can skip ahead to a SaaS solution instead of using the cloud, right? Instead of running your own thing in the cloud. But as you can see here, there is governance, and cost is actually twice, right? the top one and then the second to last one. And there were a couple of more going down this list, but I decided to cut it there. Security is implied, right? Isn't that always the case, right? So technical people will be doing technical things, and so of course they will be secure. It's implied. We don't even have to have that in the strategy, do we? Or don't we? Wait. So back to those goals again, the goal that I promised you. So when you're digging for gold, this is a company going for the clouds, and they're digging for gold, and how will we find that gold? Well, the best investment you can do is invest a lot in using cloud-native management services. there has been a couple of companies that build their own secret sauce, and we have our own management tools that we use, and they're so brilliant, and please be our customer, and now you're locked into having us as your supplier forever. Brilliant. No. So use cloud-native tools and use suppliers that give you cloud-native tools. So potentially you could exchange them, but they would know that. So now that supplier needs to actually behave all the time like someone you want to keep, rather than someone who locked you in and threw away the key. So I think that is the way to posture as a supplier. And I wanted to give you this from multiple angles. So one angle is the company that is going to consume Azure and run some services. Another one is individually. As an engineer, as a person, you would be surprised if I told you how often people come to me for career advice, and I'm like, what the heck? Really? Me? No. Don't ask me for career advice, but people tend to do that, weirdly. And so, yeah, these areas, there's lots to learn in these areas, and we are, as an industry, are lacking, sorely lacking, enough skilled and experienced, well, experience comes with time, but enough skilled individuals to tackle these challenges. So as an individual, if you want to get ahead, if you want to have pick a career path and follow that. I'll talk a little bit more in detail about these things as we go along. I kind of put all suppliers in a bucket, and I call them consultants. Whether you deliver software services or you deliver heads to work in the projects, all people that are working for someone who will be using the cloud as a supplier. Technically, of course, what we need to do, and that includes myself, is to build reusable components and reusable solutions that we can sell again and again to multiple customers. And while that sounds obvious, it really isn't for a lot of, because I've worked myself in a lot of projects where I go in and build a solution for a customer, and I go to the next customer and I build the same solution again, and then I go to the next customer and I build the same solution again, right? And it doesn't scale, and besides it's boring, because I've already built it multiple times. And the first time, if you only build a general solution for one customer, you're not going to make money. But if you build a general solution for multiple customers, you're going to begin to make money at some point. And this is exactly my journey as well. For years, we were building the same solution over and over again, but then we started to try to abstract out. And that's just good engineering, really. As an engineer and as an architect, that's how I think to begin with. I wanted to do that, but it wasn't in the plan until we started thinking, we can't keep doing this. We can't keep throwing a full team of developers, expensive, for years into a project and asking our customer to pay for that. There are more rational ways of doing it. And as you can see, I had a little fun with these pictures, by the way, these old gold mining pictures. And so I had, for this last one, I had a couple of options. Tell me which one is better. This one, I thought this second one is kind of a little bit on the nose with the beer and the drinking. So I don't know, I liked it, but not that much. I really like this one, though. This is a supplier, right? So it's Mrs. G.I. Lowe's Laundry, mending free of charge. It's kind of a little bit how it feels to supply a customer with things they need, right? So those are the takeaways. So thank you, bye-bye, now we're done. But to elaborate, right? Why is it so hard? Let's turn first to Microsoft. They're doing this, right? Microsoft is doing this a lot, so let's check. How many have seen this one, this picture? Many? Yeah, most? Yeah, exactly. This is like the canonical picture. You just follow 1, 2, 3, 4, up to 10, and you're done. Perfect, wonderful. Except we know this is the Cloud Adoption Framework, for those of you who don't know, from Microsoft, where they kind of gathered up lots of information about the cloud. And we know that reality more often it looks more like this, right? This is not a finish box 1 first, move to box 2 kind of a thing. It's all over the place. We know this. And when you have a picture like this,
special interests, if you will start looking at that and wait a minute, people and process is just like it's down there in the corner. That's the most important bit. So if you break open the cloud adoption framework, you'll find that there are a couple of versions of this picture. I hardly knew this myself, but I've been preaching this thing for a long time, that you have to start with how you organize and figure out which things are we strategically going to do as a company, and which parts might we outsource to someone else, if it's not our business. Interestingly, there's a little loop there going to 7. Starts with evaluate your need and establish the team, establish a cadence, and then 4, 5, 6, and 7, I'll tell you what they are. 4 is establish a motivation-driven strategy. Who ever heard of such a thing? Have you worked with any customer that did that? That would be lovely if everybody did. And then here's the kicker, number 5, establish business outcomes. Wow, that's innovative. I can't tell you how many customers I have worked with where the customer employees, they know they're going to cloud, right? So step number 6 is decide whether to proceed or cancel based on business justification. And we just saw that live in action, in fact, on the previous presentation, which is coincidentally kind of interesting. And then 7 is support adoption through regular cadence. But again, establish business outcomes. So the employees in the company that work for a company going to the cloud, they know they're going to the cloud, they don't know why. They don't know the actual drivers. Is it to save money is the most important thing? Is it to scale to many new customers and make more money is the most important thing? Is it because we had a security breach and security is our top concern? Honestly, mostly, a lot of the time, even the employees of the company are unclear of the actual business goals that we are going towards, which is very interesting. Big warning sign if you're a supplier to a customer and they can't articulate why they're doing it. Because then, down the line, you will come in at a point when it's time to begin to deliver some technical things. And you'll begin to deliver technical things. And here are some beautifully, well-architected pieces of software, and they're running. Look how great. You have input there, output there, everything is cool. Yes. How do we know we built the right thing? The thing they actually needed? If you as a supplier, if you're a consultant and are going to supply to someone, please ask them why they're doing it, right? And demand that they give you that answer, because otherwise down the line, you will have spent millions of their money, deliver brilliant things, and you're not sure if that was what they needed. And neither are they. And then, just as a side note, somebody else will look at this and say, well, security demands more than that, just this little tiny thing. So there's another picture in the Cloud Adoption Framework where security actually gets its own bubble. And I want to show you that. Let's see where the browser ends up, on which screen, on that screen. I want to show you just briefly from Cloud Adoption Framework. I have to do this behind my back, I apologize. Whoops, what happened there? I don't think this is going to work, so I'm going to exit presentation mode because that always screws with you. So we just get one screen, and it's still on the wrong screen. Okay, so that's not really working for me. Okay, good. Let's try. Yes, that works. So if you look at the Cloud Adoption Framework, you'll see that all the things here have their own head category. These are the things from the picture, right? And security is included there. They have their own thing. And in the whole left side menu, apologize for talking away from you. I split screen. You'll see that all of these top-level things, are you ready? It's time to adopt, and strategic and stuff, they're in the left side menu, including, in fact, organize. Organize is there in the main menu, but it's not really in the picture, except the other custom picture that I showed you.
So what am I getting at with that long explanation? I'll tell you, if I can go back to my presentation. Like this. Yes, I could. So what I'm getting at is that it's a lot. So if you pop up the Organize section of Cloud Adoption Framework, you'll get a list like that. And here's a little side note for you. If someone ever shows this many things on a slide, it's not for you to remember. It's for you to get a sense of, oh, wow, that's a lot. So did you get that sense now? Yes, it's a lot, right? It really is. A lot of things that you need to be on top of and keep track of and do well. And I've never met anyone who does all that well at the same time. Strategically, you might want to consider which parts could someone else be doing for us, like operations or compliance. How do we need to be organized to be enabled to receive that from someone else? So commonly, the cloud is mistaken for being primarily a technical challenge, and that's where many of us come in. We come in when it's time to do something technical. The business people have already decided we're going to the cloud. Do we know why? Kind of, because everybody else is doing it, and so that's why we're going to do it too. But in fact, the cloud is more a strategic business challenge, and it is a human capital challenge. So I like this part of the picture the very best. Few people start there. And when you have the business strategy, the cloud business strategy conversation, the most important person in the room is the HR director. And a lot of people forget that. We're going to have a conversation with the IT directors and the business directors and these people, and we're going to decide the future of the company. Yeah, but did you invite the HR director? It's the person there who knows which skills you have and who needs to understand which skills you need to get. Is that person in the room to begin with? Wow. Just as an example, I just wanted to put that out there. As an example, this one, right? Are we going to optimize infrastructure spend, as in we run some VM workloads and things maybe in the cloud? Are we going to optimize that spend by acquiring a bunch of reserved instances? Or are we going to instead focus on modernizing and innovating our application suite to move some of those workloads off VMs into native or PaaS services in the platform? Those two strategies are entirely different. Those two demand entirely different people with entirely different skills, right? That just doesn't randomly happen. You have to think about that, and quite hard as well. So, you run the risk otherwise of using the new cloud in the old way, right? So you run the cloud, you're in the cloud, yes, but you could have been anywhere else because you're not doing anything new. You're not taking advantage of the best parts of the cloud at all, really. So, and also the current experts, they kind of need to feel like they are included. So this one, it's a lot of information, so let's remove the bottom ones. They're not super interesting here. Managing software licenses. No. But the ones that remain, the top challenges in the cloud are, according to this survey, security, spend, governance, compliance. They're all there. And the last one, let's put that in the little box, lack of resources and expertise. So, could it be argued that if we had enough resources, we never will, if we had enough expertise, we probably also never will, we might be able to tackle these other challenges? Yeah, maybe? So it's really about understanding that dynamic. So I'm going to run through kind of, hopefully quite quick, to focus in on each one of these things in turn. Let's start with FinOps. Estimated wasted spend, self-estimated wasted spend of Azure in this survey, across many companies, about a third, right? So if you have a 1 million euro commit. You buy an enterprise agreement for 1 million euros. Might be a lot of money depending on the size of your company, right? 300,000 or more is just wasted, just thrown out. Wow. Interesting. And this is just a random picture from that I took off the internet because I realized it was difficult to take the customer ones because they would be real. And so this is Contoso. This is what I found on the internet. It's quite old, actually, I think. But what I want to highlight is actually something small in this picture, is the budgets and the cost alerts. So I see a lot of companies not even have considered using budgets in Azure. It's not a requirement, but it's a really, really handy tool, really handy. And why is it so handy? Well, if you start allocating budgets to your spend in the cloud, if you manage to get to that point, you will put either a team manager or a whole team responsible for the spend in a way that they begin to feel accountable for what they do. So many times I have seen people deploy a test VM, something, and leave it running and forget about it over the weekend or forget about it for months. I literally came to a customer and I was like, okay, started looking at what they had in Azure. Oh, there's a little VM scale set right there, 5 VMs, and there's another one of 5 VMs running. What's running on these scale sets? 10 VMs running. The lead architect looks at that and goes, oh, we still have those. I don't think we're using those. So 10 VMs running for 3 months just because nobody realized they were running and nobody turned them off. And yeah, well, so clearly no one was accountable for that, right? So fixating a bit on budgeting and twiddling with that, including your professional engineers, your tech people to be, that's us, right? Most of us in this room. To allowing us to be accountable is not something negative. It's actually something that makes us feel proud and makes us empowered and strong. I can now do this because now I know, right? Seeing things like this is only 500,000 Danish, so about 50, 60,000 euros, right? So it's not super much, but these are cost recommendations, things that you could be fixing, right? Buy virtual machine reserved instances to save money. Yeah, technically, that's really easy. You know this, technically very easy. I can go click, reserved instance, yep, off we go. And then you go to your manager and say, listen, manager, these VMs, and we have this recommendation, and a lot of money could be saved. Can we buy the reserved instances for that? And they go, we need to think about whether or not we're going to run these workloads for a long time. These are reserved instances, right? So it's 12 months or 36, right? So are we going to run them for a long time, or are we actually migrating sometime soon? Sometime soon, you know where this is headed, right? To PaaS services instead. Yeah. And then months and months later, right? Sure. We know there are Azure cost management optimizations that we need to attend to, right? We know that. But 7 months later, when your enterprise agreement runs out and you still haven't done anything about it, it's painful. So this is a story. I'm going to make a long story kind of short in the interest of time. They had a 12-month, they had an enterprise agreement for 12 months. They had some performance issues. They wanted to turn off auto-scaling for a while to find out what the problem was for just a short time, and I advised against it because do you actually realize how much that's going to cost you? Well, yeah, this was about 4 months in, so 3 months additionally in, 7 months out of the 12, they had spent their entire budgeted enterprise agreement, and yeah, they had to now figure out how to get extra budget for additional 5 months, right? This is real. This keeps happening because people don't measure and don't realize. So consultants, create financial analysis services, offer Cloud FinOps training to your customer. Like the best customer is a knowledgeable one. right? Stealing, candy from children is kind of nice, it's sweet, that lovely lollipop, like children crying. Train your customers. Yes, a lot, because then you can start to have adult conversations with them and not adolescent ones. And prepare to help them strategically. So demand that they know what their strategy is, because you'd be surprised how many actually are a little bit unclear, apart from the fact that they're going to the cloud because they're going to the cloud. Right. As an engineer, here's a learning path. Microsoft loves when I do that. Refer to their docs and learn and things, right? That's a thumbs up from Microsoft on doing that. So learn about this. If you have a big company, if you have a big spend in Azure and no one has gone through this learning path in your company, you're just randomly using Azure. You don't know exactly how much it's going to cost or what you could do about it with the budgets and stuff. We're not using budgets because we don't know how to use them. Is that an excuse at all? And then as a customer of Azure, using Azure, figure out do a financial analysis for the spend and have that uncomfortable strategic talk where you talk about should we go left or right, IaaS or PaaS, or that's the example here, but there are many other things that you need to choose from. Do not forget to include HR in this conversation. Many people do. And then, for heaven's sake, please implement those cost advisories. There's no excuse for, 6 months later you still haven't touched them. All right, let's go to compliance. The common status of non-compliance, here is compliance at 12%, right? I think you have seen something like this. You may have, yeah? This is a common case. This is actually just the random things that you happen. This might be just because you deployed something that was default, right? The 12%. You deployed something and just happened to have a setting that was set to something that actually was compliant. So the 12% kind of signals that, you threw a bunch of things at a wall and something stick, right? But really, to miss compliance this much is common. And then what to do about it? It's hard, and why is it hard? Because you can invest a lot in compliance, and then you'll notice that compliance tends to move. This is the AZ Advertiser. Very, very nice service. It's on the internet, azadvertiser.net. Anyone can browse to it. It shows you which changes are made to compliance in Azure, right? And so to focus in a little bit on the bottom picture, you can't read it, so I'll have to read it to you. This was a picture I took at the beginning of this year, so it's from the end of January, beginning of February. January 28th, there were 83 total changes, updates to policy. 83. About a week later, almost a week into February, there were 14 new changes, 10 updates, and 4 new policies that were created. And a week after that, there were 8 new updates and 12 new policies. So in less than a month, there were 117 changes to compliance in Azure, right? So even if you invest into figuring out compliance, it's going to move for you, right? So we put a lot of effort into fixing compliance. It's almost perfect now. And then, but the cloud changes and now you're out of compliance again, right? So that investment, what are we doing? Or we're trying to catch clouds with a net, right? They keep slipping through. Here's another version of the same. We know compliance is a must-have, and we're trying to do it, but getting governance in place is overpowering. So a customer of mine had a CSP relationship, and so they supplied a bunch of things, and they wanted to have them set up compliance, assign policies in the right place in the right way. And so they opened up a ticket to get a change made for just one policy to fix that. And after a long time, that one policy was assigned in the right way. And then they realized that we don't have the organizational structure to govern this and manage change in policy over time.
So actually just doing it the right way is difficult to begin with. So, consultants, create compliancy analysis services and operate your customers' compliance for them. But the last one is kind of interesting. Create compliant deployment components. So we have a library of those, things that we have built to be reusable. If your customer has multiple teams, and multiple teams are deploying multiple instances of resources, they all need to configure those to be compliant individually, right? So each team has to do it in turn, right? And then they need to maintain it over time as well. So what you should be doing is taking a big step, whoa, let's not fall off the stage, taking a big step back and abstracting out. This is just good architecture now, right? As responsible engineers and architects, create a deployable component of a SQL server, which is compliant, and then have multiple teams use the same deployable component, yeah? And when compliance shifts, which it always does, clouds tend to change shape, that component will be no longer compliant. You fix it in one place and you ship a new version of that, and all your teams can upgrade to the new compliant version without having every individual team realize they're out of compliance, trying to figure out what to do about it, and changing their deployment individually to then again be compliant. You realize, everybody here quickly realized the waste of that, yeah? So, if you're a customer on the other side of the bench, you're not a supplier right now, you're the customer, you're going to spend on Azure, centralize your compliance governance, because there needs to be a plan. So many times I've seen, the management trees in Azure you can have with different areas, and then you can have subscriptions in that little tree. So many times I've seen that they have dozens or more of subscriptions hanging out in the root of the tree, and they don't actually really have a tree of compliance. The main value of the management structure in Azure is for policy assignment. That's the main value of it. I've even asked Microsoft about that, and they were like, yeah, you're right, that's exactly why we did that. So that large enterprises and large organizations can have a section of the tree with some subscriptions that are for development and another section that are for production, right? And they can assign policy differently across those, right? That's why we do it, and I see so many are not doing that, right? I see so many are, well, we created this large enterprise subscription, and now we have dev and test and prod and pre-prod in every environment in the same subscription. Technically, you can have it. Is it a good idea? No, not really, because now everything has the same policy or not, and it's all a big jumbled up mess. So, vary compliance by environment. That's what I just said. And then invest in reusable components, right? Because that's also empowering for your, because that's also empowering for your less tech-savvy teams. As in, when I say tech-savvy, I mean like if you have someone whose job, it's not their job to be a developer or an IT engineer and know everything about the cloud. Maybe their expertise is in technology something different. They're a data scientist or somebody, right? The data scientists, they're tech savvy as heck with that, but not cloud. So they want to deploy things to the cloud. They want to have, your data factories or your machine learning things, and that's their tools that they want to use. They don't actually care how they run in the cloud. They shouldn't be bothered with compliancy and things like that, because it's not really their business to know that. They want to have something deployable easy, and when they use those things, they are compliant, they are secure, they are great. All right, career path for engineers. This is harder, right? Because how do you fix compliance? Well, you fix compliance by being good at Azure. So it's not like this one requires some tenacity, and it requires that you do this a lot for a long time. Let's see if we can run through security here as well. Right. Quick comment offhand, unrelated to the rest, about Azure Security. Wait, no. About Microsoft Defender. Flavor of the month.
It amuses me how often the answer to security threat in Defender is to buy another Azure service. And a lot of customers observe this, right? A lot of companies that are consuming Azure, they observe that when they look at Defender, and they go like, yeah, great, so just buy everything that Microsoft have, and then you're secure. That's basically the message. You need to be careful there. But that was unrelated, sorry, I couldn't help myself. Security scores. Here's a lovely picture. I like this picture. I call it half secure, right? How secure are you? About half. Right? But for those of us who work with the secure scores, we know that there can be like one thing you fix that is like 25%. So it might quickly get up. But what I often see is things like this. There are 611 active alerts. That's overpowering, and I see a lot of organizations are not set up. They have they're coming to the cloud, so they have, of course, their own security department for their on-premise stuff, secure network and physical security and all these things, but the same people are not experienced with using cloud things and cloud services and things to ensure security in the cloud. So they don't really have they have a security department, but they don't have a security department. And the problem with that is that the managers, the business people think they do, but they don't. So it's actually nobody's real job to fix that. And so Microsoft Defender is blinking all of these red lights. Can we do this one together, by the way? Can I get some help? Right, let's do this one together. Microsoft Defender is blinking all of these red lights. Everybody together, but. Oh, thank you, that's a nice but. But we cannot even begin to prioritize how to fix it because we don't have the right people with the right experiences in the right seats, and it's nobody's job to fix it. I've literally asked multiple customers this question: who is fixing the secure score? Where is the backlog for fixing the things that show up as a negative secure score? Nobody's job. Wow. Interesting. So again, that's when the business looks at security as something that will just automatically happen because engineers are doing technical things. And it's not the case. It's not true. So if I look for security things as a learner, there are so many. Here are a few. You can learn all about security from Microsoft, about how to use their different things. So there's tons. Create security analysis services as a supplier, as a consultant, right? So we can help you. We can analyze your security posture, and we can tell you where you are. This is a great thing to do as a consultant, and operate their security because they're not doing it. So you can offer them to do that, and then hire all the security specialists that you can find. And when you realize you can't find any, you begin to train your own because there is a shortage, a massive shortage in the industry in this area. So. For customers of Azure, the company that uses Azure, please set up that SecOps, cloud SecOps department thing. A lot of people don't have one. They're spending millions in Azure, but they don't have a security office for the cloud, interestingly. So hire all the specialists and consultants that you need, because it's like, yeah, we will have a security department for the cloud operations sometime soon. Okay, where's the plan to get that? Oh, yeah, didn't you hear what I just said? We will have it soon. But there isn't an actual plan to get there, interestingly. And make security strategic, for Christ's sake, right? Open up the cloud business strategy plan document thing and find the word security. If it's not in there, that's because the business thinks it's automatically going to happen, and they don't understand that it won't. So, ensure that it is somebody's job to fix the secure score. Whew, all this ranting. All right, final leg. Azure Monitor Advisors, I love this. So you can get to an Azure Advisor overview that looks like that. All the subscriptions are selected and there are no recommendations. It can be done, right? There are no additional things you need to do. But more often it looks like this, that there's, you can save 2.5 million Danish. So, it's possible to save a lot of money, but no one is doing anything about it. And what's worse about Azure Advisor is that it has history. It knows what you haven't done. Oops. This is sort of a sackable offense, if you ask me, honestly, right? Let's look at that. For months, and this is just a quarter of a year, but for months, nothing has changed. And they're not all bad. People are honestly doing good things as well. Reliability, operational excellence, performance, it's, top-notch according to Advisor. But security is down. It's not terrible, but it's not great. And there's a waste. This is same customer, actually, so it's about 500,000 in waste that could be optimized, right? But for months, no one has done anything about it. The reason I see a lot of the times is that there's too much information. It is information overflow. There are so many blinking red lights that you don't see them anymore, right? That is a huge problem. Now, we're taking questions at the end, so I will wave a little bit more, and then we'll go back to questions. So, Azure deployment environments, just as a note, Microsoft are now publicly talking about it, the thing called Fidalgo. Lovely, take a look at that. How much time have you spent enabling customer teams to do some self-service to get a new subscription or get a new deployment environment or get access to something? Building that self-service, well, it turns out everybody has that problem, and everybody's trying to build a solution for it. And so finally, wonderfully, Microsoft is also doing the same with Fidalgo Azure deployment environments. That's a brilliant thing to take a look at, by the way. And I do need to stress one thing as well, and I also love to jab a little bit at Terraform. I love Terraform. We use a lot of Terraform in my company. A Devo team is like 8,000 people, and so we have a lot of people working there, and so many of them use Terraform, and it's fine. It's just that, right? There are also the native ones, AWS CloudFormation templates and Azure Resource Manager templates. As it turns out, according to this survey, and this is what I'm seeing as well, they have uptake, they have increase. More people are starting to use that more, the native versions. And actually, there's a slight decrease in Puppet and Chef and Terraform in these things. There are like across that you could use anywhere. Now, I know that someone here who loves Terraform is personally offended right now. That's okay. I don't mean to offend. Terraform is brilliant. I've said it several times. It's just that the providers of your clouds, they want you to use their stuff, of course. They want to lock you into using their things, so they want you to use ARM or Bicep, or they want you to use AWS CloudFormation things, because then it's less likely that you want to move somewhere else. All right, so how to avoid security and compliance problems is to never be non-compliant to begin with. So you start with a library of secured and compliant components, and then that is something that you might consider, and this is kind of what I sell, so this is very self-serving, so I kind of apologize for that. But again, you could buy that from other companies than ours. So it's a good business opportunity because of that. About half of companies are using managed service providers. About 31 are using it some, and 26% are using it a lot. But there's another 12% planning to use it, according to this. So managed services is very much on a rise now, where people are, I think it's a sign of industry maturity, that we don't want to build the same solution again and then move to the next customer and build it again. We want to be smarter. So if you think it's expensive to hire an expert, wait until you hire an amateur. But that's it, actually. We're down to, like, we can stop now. You never arrived at the cloud because it always moves. You must learn to live in the cloud like a pilot, and clever businesses get a guide. And that's it. Thank you. I hope that this was somewhat informative, and if anyone has any questions, it's kind of a general talk, but maybe you have a specific question. I think I'm off the hook. You have one.
Like the whole scoring area, secure score, advisory. As you mentioned, it's a lot of information.
Yes.
Customers get overloaded. Do you have recommendation on, is there like a sweet spot to start with the most high ones and then create a backlog of the other ones?
Yeah.
What's the advice on that?
It's a very good question. So the information overload, the question is, the information overload that we see in these secure scores and these advisories and dashboards, like I said, there are so many blinking red lights that you can't see anything anymore. How do you begin to untangle that at all? You have to, you know that you have to, but you're kind of deferring it because maybe someone else will take an initiative, I don't know. So how do you do it? You analyze first. You need to, there are great analysis tools and there are great companies that do nothing but analyze things for you. So if you feel like you should get an expert's opinion, you're probably right. That's my recommendation. Get a report. You still haven't bought anything except the report, so now you might know where to begin to look. And then you'll find, you know, the low-hanging fruit, like, oh, that thing is easy to do, right? Oh, we didn't have a firewall installed on all our VMs. That's crazy. Oh, easy to do. Click, click. You know, now that's done. And then there will be the more long-running ones that require a lot of more attention, and some of them also require a strategic conversation. So reshaping your initial report into a backlog and making a prioritization, I think, is very important because you will find some strategic conversations in that you didn't know were there. It looked like technology because it was a dashboard with blinking red lights, but once you weather it down, once you analyze it, you realize that there were hidden strategic conversations for the business that they didn't know they had to have. And so now you can have those conversations and figure out, okay, what is our actual plan for having that SecOps in place? We can't find the people, we can't hire them, right? I'm just using that as an example. They're not in the market, so how do we approach it? Well, now we have to get a service for now, maybe, require the services of some security expert consultants. Might be expensive, but not having them probably, in the end, eventually, inevitably going to be more expensive. So, and then make a plan, right? So you need to analyze and break it apart and find your strategic questions that are hidden there. Kind of a long-winded answer. Does that make sense? Absolutely. Wonderful. Yes?
You talk about acquiring the security consultants from elsewhere.
Yeah.
I feel like a lot of the recommendations that are on the Azure, on the security side, are common sense. So how do you approach on actually getting the people in the company to get that common sense so you don't actually need the consultant? Because it will happen in time that it will become common sense that you do not open the SSH port on a public server.
Yeah. So to repeat the question again, that's a brilliant question. How do you, like a lot of the security recommendations and things that you see in these long lists of things, they're common sense. And if you put that in front of an engineer, they're immediately going to go, yeah, that makes sense. Of course, yes, we're going to fix that, no problem. But it's not really someone's job to do it, right? So it's never getting done because it's not getting done. And remarkably, it is astonishing how uncommon common sense is. Because we tend to focus on the thing that drives us forward. Like if you have a some business manager somewhere requiring new features to the application or what have you. Those are things that they're shouting at you to fix, and so you will fix those, and you know you have to fix that security thing as well, right? You know you have to do it, but it is not prioritized right now, which means never. And so finding the right people to help you if you don't have them is something you must do, and you must make security strategic, right? So it is strategic. It has people assigned to it whose job it is to fix it, because it doesn't automatically get fixed when you have other deadlines, other things pressuring you, right? We need to get the features out, and sometime later we'll fix that security thing. Sometime later never happens. Yes? It's what's wrong with the world.
Sometimes the company needs to buy a consultant to tell the manager to do the thing that the team already knows.
Yes, exactly right. Yes.
You're here and everything, but this consultant, they're paid.
Yeah, Sakari runs a consultancy company, and so he knows this story very well, right? It's the fact of life, right? That you hire a consultant to tell the company to do the thing that the engineers already know they need to do. And that's the sad truth of it. It doesn't happen automatically. That's the thing, right? I've been hammering that many times in this presentation. Let's do it one more time. If it is not someone's job to fix it, it's not going to be automatically fixed. But the business end of your company thinks it will be fixed, because engineers are doing techie things, and of course they'll fix security. Sure, not without a plan. Yes?
I think it feeds into the accountability, so it is also in the you build it, you run it, you get the accountability on it. And that is when the fixes start to flow in.
Yes, two wonderful points. Thank you for those, and maybe those will be the closing notes. Probably, yeah. Wonderful notes. So, yes, the accountability again. Professional, adult, responsible engineers doing techie things want to do a good job. We do. We are proud. We are good at what we do. We love to do a good job, right? And so we need to be accountable for the job that we do. If we're not made accountable, we're going to waste money, because it's not my business. It's not my problem if I leave the VM running with an open port to the internet. It's not my job to fix security. It's not my job to blah, blah, blah. I don't feel accountable, right? I don't feel like somebody requires me to do the right thing. That is so important. And the other one was, you had the other point there. You build it, you run it. I love that. So the sad part about you build it, you run it is that it doesn't scale, right? If every team needs to operate their own shit, we're going to have each team having operational people, and they're not going to be coordinated anyway. So all the teams need to be able to rely on an operation as a service. That could be in-house, but that's typically something that we see a lot, that people try to ship off to somewhere else, like Lithuania or somewhere where the headcount is cheaper, to run operations for you. So I have to honestly say, and this is maybe I don't know if it's an unpopular opinion, but I think you build it, you run it, it's kind of bullshit. That's my opinion. All right, are we done? Thank you.
Hey, that was the morning of the first day. We will now have lunch. We will have 1 hour to eat the lunch. Please eat together and talk. Not while eating, but while, swallowing or something. Thank you. No? Yeah? Yeah, same difference. We have eaten. We have chatted. We are present. You hear me now. Did you say louder? Oh, I'm so sorry for the low voice of mine. Before we start this session, azure.ly/SD1 is the survey for day one. It has stars for all of the presentations. And across the presentators, there's a bloody battle going on. Who is number one? Who's the best presenter? Now it's gonna settle the whole year. Like some people will leave this country bummed, and some people will leave this country and their wives, and the wives will be very proud. I'm not sure if that's true, but in some cases maybe. So please at the end of the day, or even now, go to that URL and give some stars to the speakers. And then when we are with the presenters at a cabin in Finland this weekend, we will reveal those answers. And some presenters will drink in joy, and some will drink in pain. But both will drink. So that is very important. My session is splendid because I cannot prepare for it. This means I can just come here and do my thing, and you will be either happy or not. We will design a platform as a service application on the fly. I have a few slides about the basics of platform as a service applications, and then I will ask you guys what kind of an application we will design. And I will wait until you answer. And the wait will be uncomfortable. Even more to you than to me. I'm happy being silent. I'm the silent type. Thank you. So, Sakari Nahi, what I wanted to highlight is Ikkuna Studio, a Microsoft thing, a podcast that we've been doing with Jouni Heikkiniemi for 6 years. There might be every now and then episode that is interesting, so check that out. Otherwise, no new stuff there. And Azure, we build stuff. This slide I added because we opened office in Denmark this year, so I wanted to say that out loud. To platform as a service. I said that Magnus has said the cloud is commonly mistaken for being primarily a technical challenge. It is in fact primarily a strategic business challenge with a human capital challenge. Now I heard Magnus say this, it's been quite a long time. And in this talk we will focus on none of that. Instead we will focus purely on the technical challenge, which is, let's face it, the more interesting one anyway. I'm not saying that everything is possible to do in the cloud with platform as a service, but I'm saying it is possible to do with platform as a service. There still are things you shouldn't attempt to do with platform as a service. You do not get full control on all of the resources you use. In some cases, if you have a factory running in Rovaniemi and you need to control the production line of that factory, maybe it doesn't make sense to have the controls for that in Amsterdam. So there are some cases, but unlike 5-6 years ago when it was common for us who were doing this then to say to client, this is not a case I would build on cloud right now. It's a different world. It's very rarely a business case or business need cannot be met with platform as a service components. Why would you look at platform as a service components when you have perfectly good cables in your cupboard? There are some reasons. Infrastructure as a service is something people are very familiar with. We know how that works, and that's an advantage. You get a lot of control, that's an advantage. But you also get a lot of administration work. There's slow time to live, you need to wait for stuff, or you need to configure stuff. It's hard to scale If you have virtual machines and you run out of that virtual machine, you need to scale with another virtual machine and so forth, but it is existing knowledge. And then platform as a service at the other end, on that side, you have less control to those resources that are provided by platform, but that also means you don't need to look after them as much, so less to administer. Therefore, you get fastest results if you are trying to build an application or a solution. You just set up some PaaS service, you configure it less than you would if the other option would be to install a virtual machine. And it's easy to scale because Microsoft has all of these mechanisms that let these resources scale with usage. And of course, they bill for that. So it's nice they have the mechanism for them as well. But it's new knowledge, and we had 2 talks where it's clear that this new knowledge bit can be demanding and requires the support of the leadership team of that company. In between, there's containerization as a service. Best of both worlds, one could say, except that Kubernetes is so goddamn hard that I'm not sure if it's the best every time. But with those kind of things, with Docker and Kubernetes, you get more control than with platform as a service, but you get more stuff to configure, and it's also new knowledge. It's not like if a team goes to a project and they do a Q project, it's not guaranteed to succeed, right? We all know that. So we are gonna err on the side of platform as a service in this talk. And at the end of this talk, my promise is that you've seen a person who's done this for 10 years now to Azure. Do it. Like, I don't know if you agree with me. It might be a huge fail, and that's what we are hoping. That would be entertaining. Or it can be a success, and then you maybe learn, okay, this is the way Sakari looks at those things. This is an example of where we could end up being. We are coming to a diagram like this. This is something we built for Seure. They have this mobile application for 15,000 workers who every weekend or week or whatever look for jobs or gigs, as they call them. So here, worker is searching for Helsinki Päiväkoti. So that's early childhood education professional view. And here's the architecture. You see there's the source systems down below, there's the ERP system, data, Snowflake, some robots. We get that data to storage. We do some stuff with the data with Databricks and Data Factory. Then we push that data to clients, to mobile and web applications via API management from APIs, concrete API implementations. And there we have eventing or messaging of some kind, so we can have serverless workers working on some specific processes. That's the amount of boxes or things we will see. On the topic of amount of boxes, if you go to azurechart.com, you can check what's the state of Azure from someone's viewpoint. And there are quite interesting features on that site, including this heat map of what services have been updated lately by Microsoft. And that's interesting since every now and then, some services on Azure are sunset. Microsoft decides that, okay, this data lake version 1 is very bad. We're going to have to sunset this. This will be obsolete. We're going to have data lake generation 2, which will be superior. And those kind of things might sometimes be possible to predict by going to Azure charts and seeing if the resource or service you are thinking of using is receiving updates often enough. So when you start the next greenfield project, you start building something, go there with the team. See if the pieces you are looking at, if they are so mature that they don't need updates, or if they're so shit that nobody's updating them because Microsoft is thinking of replacing them. There's plenty of services. Now in this talk, white boxes came up. In this talk, we will be looking at mostly these areas. When I ask you soon, in a few minutes, I'm going to ask you for an idea to design. If you have some kind of an IoT sensor idea, or if you have a data warehousing idea, then these boxes are wrong. Then we will use other services. But if we are looking at custom application development with a front end on mobile or web, these are the things that we will look at. And now when you look at this, it's not that scary. You've done Azure or you haven't done that Azure, there's just 10 boxes you need to know a little bit more about, and you can go forward with creating the base architectural thinking of the solution. A few words on these. First is running the code, the compute on platform as a service. So your people, they develop something, and then all of that code goes somewhere in a packaged in some manner to Azure, and App Service and Azure Functions are the two most common services used. The difference being, of course, that App Service you pay for a monthly price for a certain size of a machine, so their infrastructure is quite close. You decide how much memory it has and so forth, and then you have your payload running there all the time. And then Azure Functions are serverless components that are triggered by a request or by a timer, you know, it's 12 o'clock, let's do this integration or whatever. So these are the two normal choices. And usually, if you are doing an API that is supposed to respond to the queries from a mobile app, app services are the go-to tool, because we cannot guarantee if your Azure function is on a consumption plan. We cannot guarantee it wakes up in time so that our user doesn't get frustrated. Now these two are getting a brother. They are getting a friend that was generally released and became generally available in build now. Azure Container Apps, which is kind of like managed Kubernetes, but since there's managed Kubernetes service called Azure Kubernetes Service, then Azure Container Apps is something that's closer to platform as a service, but you still use Docker or containers as your packaging mechanism for your code. And then you can use Azure Container Apps where you push your containers. You can use that to define ingress and domains. And you can use KEDA, and you can use Tapper, and you can use all kinds of things. So Azure Container Apps, if you're not that familiar with that yet, then why would you be? It just became generally available. I'm not that familiar with it. But it's somewhere between these two guys and Azure Kubernetes Service in the middle. You're still working with containers, that's how you package your code, but you don't need to configure the running as much. So quite excited about that one personally. Once you have your code running, you need some data in the cloud. We are not talking about Synapse. If someone says data and it's Microsoft Scope, the next word is usually Synapse. Now we are talking about applications where Synapse isn't the go-to tool. Cosmos DB and SQL database, Azure Sql, are the two regular tools. Cosmos DB, to how many of you is this tool familiar? Raise your hand if you worked with it. Like half. It's this multi-model database that has documents and key value and other ways of storing stuff, and you can scale it globally infinitely as long as you have the dough to pay Mr. Mark Brown here. He will later come here on stage and say, yes, all the money comes to my bank account. Basically with those words, I think. Cosmos DB, let's not talk about SQL. We know SQL, it's a great relational database. Cosmos DB is a tool that's been used wrong for a number of years, and it hasn't been made easier by the Cosmos DB team who's designed it wrong. And now they are fixing these things. Nice, Mark. What Cosmos DB is, why is it so great? It is the only database you can use for a month and use it to serve 1 billion requests in a month, and it will cost you 20 euros. You cannot serve 1 billion requests in a month from SQL for 20 euros. That's not possible. With Cosmos DB, you can. That's possible. I think most of the teams here who have worked with Cosmos DB, the experience has been the opposite. It's been the opposite. There's a little bit less calls than 1 billion a month, but the cost hasn't been 20 euros a month, it's been like 2,000 or 3,000 a month. That's the common experience with Cosmos DB, and it's a thing that Cosmos DB team clearly is looking at closely. If you look at the build releases now, what's coming, what's in preview in Cosmos DB, there's these burst mechanisms and there's this repartitioning capability and all kinds of tools that can help you manage the cost of Cosmos DB. And today, the fact is, if you design Cosmos DB correctly, it can be efficient and it can be cost effective. And I think Mark will be speaking about that directly. So that is an interesting tool that can scale quite high. And then we get to the binary storages, the even cheaper, even dumber storages where you want to put a lot of your stuff. There's data lake storage and there's Azure storage, and they're the same tool, but data lake storage has one toggle on hierarchical namespaces on Azure storage. So the pricing for both of these storages is the same. They have some different access control mechanisms. Azure Data Lake Storage has a real folder structure, while Azure Storage only has key value keys to find blobs. So you can't modify or work on multiple blobs with a single key. That would be the folder, so to say. With Data Lake, that's more robust mechanism. If they're the same price and Data Lake has more features, why would you ever use Azure Storage instead of Data Lake? The answer is that Data Lake will generate more data. For every file, JSON, whatever you push there, Data Lake will generate a metadata file that will contain the configuration of the folders and access control, all that stuff. So if you have a storage for 1 trillion small files, Azure storage will be a lot cheaper. But if you look at the Azure pricing calculator and you look at okay, these are the same price per terabyte, it will feel like there's no difference, but there is. What's interesting is that with Azure storage, I said that they're dumb because they're key value. Azure storage received a while ago this capability of indexing. When you build, I don't know if you were aware of this, I noticed last week that not many people are. If you put data into Azure storage, you can configure some of the attributes in your payload to be a basis for an index. So if you are just searching for certain data with certain attribute like city or, I don't know, surname or something, you can have that, in addition to having it in the key, you can have it in the index of Azure storage. And then the storage looks into your payload and indexes your files with that. So it's not as dumb. It's actually, in some cases, it's a pretty efficient replacement to SQL if you don't need a lot of joins and complex queries. Check out the indexing. Then we have the messaging. We need to balance load. We need robustness, we need reliability in our application, and for that to happen, our API, which gets requests from the clients, we don't want that API to crash. So when data comes in, we want to send messages to whatever eventing mechanism or service bus, and then Azure functions or other serverless processors that cost per time, when they run, they do the processing, for example, generating a report. Azure DevOps for CI/CD, IAC, and stuff like that. Key Vault for secrets, and Active Directory. Active Directory for of course, some kind of authentication. Of course, you can have Okta or Auth0 or this kind of stuff, but you will have Azure AD anyway, and for your internal employees, that will be, free of charge. Although now of course, it's Microsoft Entra, which is Azure AD, and then it has this permissions management that was CloudNox that Microsoft purchased a year ago, and some verified ID thing. So Microsoft, they just created a new product that contains a bunch of identity products, but nothing changed in Azure AD in that sense. Cool. Now, we spent some time walking through some pieces that we will use. You're not familiar with those. I don't have to speak about those as much when I'm drawing. And now we will have a long, uncomfortable silence until someone shows an idea for an application. Maybe you're working on an application. Maybe you have to design an application. Maybe just shout what's the need and I'll do the design.
There's a flaw in your plan. Finnish people like long, uncomfortable silences.
Oh, it's not a flaw. I don't see any hands up. So the thing, to presenters, it's 7 seconds when you ask a question. The average global is 7 seconds you have to wait. Pasi, you are ahead of time. What's your idea for an application?
I've been doing some market research and it seems that there's a global growth mean and all these users would like to know kind of where can they find the nearest mean to.
Okay.
And if we go a little bit further, we could maybe sell the data we get so we can see where the largest needs for mean puzzles are. And
is Alko your client? It starts to sound like Alko is your client. Okay.
And people can make orders by putting a PDF into an email attachment.
By putting a PDF into an email attachment. Thank you, Glenn. I will love designing that feature. Shut up, file stream SQL, man.
Online training courses that teach you how to stack the bottles of Mewtwo when you finish.
Oh, but this is technical talk. I don't. That's not, the training isn't my cup of. That's not my cup of tea.
I can learn more techniques on drinking.
Oh yeah. So videos like self-help videos on how to guzzle faster. Okay. So there's one idea about the global reach of a beverage. Do we have another idea, sir?
Very great, it's full of ice cream, and it notices which ones are going empty, and it sends request to order API, the order more ice cream, and it sends you a Teams message to approve the order.
There's too much Office 365 in that. Teams request, my God. Thank you, sir. You unknown person who eats a lot of ice cream from the fridge at the office. I want to, sir.
A camera app for Jenga, which calculates the best block to take out of the tower.
Oh, God damn, that's... Camera for Jenga calculates the best block to take out of the tower. That's an interesting one. Can we get one more? Sir?
Maybe involving that, like...
involving the mean to idea, you say? Yeah.
Like, where is the nearest place, where is the free place in Terras, and they're serving certain thing, and how to get there?
Okay. So, I heard one idea about self-fulfilling fridge, one camera thing that would be interesting. Then we had this drinking thing. If we expand the drinking thing into a product thing, that we get some products, maybe we can get with that. First, I need the business framework. Sir there who gave this idea, is this application created by the business who produces these beverages and edible products? And for what purpose? Is it for them to follow, okay, for example, companies like Puuilo and Motonet. Do you know what's the problem? The problem is, where do I put this store? Where do I put this store? They are, in Finland, there are places where people buy grills and shit, okay? Where do I put this store so that I know that people nearby come and buy grills from us? That's what Puuilo and all of these companies think about. What's the most effective location for a store? So this example of this application idea of following where people consume the product that this company needs, that's actually very meaningful to a lot of companies. So if I just keep on rolling with this, we have this business need by a director or a manager who says, we are doing this product. And we see it going and people are buying it, but where are they buying it and where are they consuming it, and should we get it more accessible to people? That would boost our sales, right? People would know that it's nearby and it's, readily available at all times during the night and day and morning, like Mintu enjoyers like to have. So let's start designing that kind of a thing. No, not the takeaways. Okay, so here we have my favorite program, Draw.io. No, it's not. Why? Oh yeah, there's the, what will we design today? Let's take that out. And then we open the Draw.io. Here, we will draw things. We have plenty of time. At the bottom, we have data sources. Up top, we have apps and consumers. In the middle, we have Azure stuff. Go Azure. So, we have the business need. Like Magnus said, you need to always know what's the core, what kind of return on investment the company wants for this application. And they want to know where is this product consumed. Okay. Now, that sounds like a reporting thing, right? Decision makers want to see a report. What is the local or postcode where these things are consumed. So let's not stay at that level. Let's make it a social thing, okay? So you buy a product, Rik buys a product, and some other person in this room also buys this product, and they want to have a chat about the product, and they want to find each other. So let's make it a mobile app. There's a mobile icon. It's not big enough. I'm sorry, all of the icons will need to be, I'll just constrain. There we go. And this is the mobile for product usage thingy. That's the best name for an app ever. Mobile for product usage thingy. And then we already know, because we wanted the, what's report? There's no Power BI icon in this Draw.io directly. So let's have this kind of thing here. And height, 69 is wrong, 50 is good, so that this diagram is ready for the client, right? Reporting about good locations for directors. Cool. Now we have here the two things that our users need to see, two different user roles, right? The next thing I want to understand, if this is the impact we want to create in the users, the next thing I want to understand is the ecosystem. The technical ecosystem, what are the systems around our application, which is greenfield, this never existed, what are the systems we need to communicate with? So I'm thinking, since we are talking about, what are we talking about? We are talking about products. So there's going to be some kind of a PDM or PLM, that's product data management or product lifecycle management, right? Then we are going to have customers, because customers buy. But of course, if customers are resellers, we produce this thing, and then it's a reseller who sells it. Still, it will be some kind of a customer who's bought our things. We're going to have CRM as a system. And then what else? We're going to have MDM for some relations, maybe, I don't know, master data management. And then we are going to have like images about the products and stuff. Oh, SAP, yeah, let's just add, like, let's cover this MDM by SAP, so we are very, very much on the road to chocolate future. So now here's our ecosystem. Where I begin, I started coding at Silja in Tallink, Silja 2001 or something, with .NET 101 or something, 2002 maybe. And I learned to look up the data first. I know that in today's world, there are people who look up the user experience first, and the cases that people do, and that makes sense. But it's not how I do things. I look at the data, and I'm like, okay, what kind of data we get? So let's think about the data we are getting. We are getting products, and we are getting information who bought the products, the reseller, and then we are enriching that with the data we get from the mobile. When Rik bought it and he's like, hey, I'm here drinking this product that you produced. So we know that there are relations. So the first thing that comes to mind is a SQL server. For customers, and customers and products kind of thingy. And the other option would be Cosmos. Mark is here. The other option would be Cosmos that we spoke of, where we wouldn't have relations, we wouldn't do joins, we would instead have a document that would contain all of the relevant attributes. Let's, for example, if we have resellers who sell our products, let's have resellers and products in the SQL, they have relation. And then we can do the Cosmos for the mobile app. Let's say this mobile app is global. I don't know if it is, but let's have it this way. And mobile app users and geospatial data. Nice, geospatial data. Cool. So, yes, sir.
So if you're tracking relationships between the people who are consuming and each other and the retailers, could that not be a graph?
That could be a graph. That could be a graph very well. And then Cosmos DB would, of course, be a good tool for that too. That's a good point. But I won't go anywhere with that point. It's an excellent point. Where I wanted to go with the geospatial is that if we are having a map where we can see people, I don't know which one is the right logo for Azure Maps. And I don't know if you're familiar with Azure Maps. How many of you have done some kind of mapping features with geospatial data? How many of have you worked with front end that has some kind of, cool, there are some hands up, not too many. My layman's understanding is, from our perspective, if we were creating an application in the cloud, and the idea was like this that we have, where we want to see where people are working with our products, we have approximately 2 rough choices. The other one is to have open source geospatial server, like Geo server, which is a product, you can check it out, or map server. You can have Geo server or map server in a Docker container from the web page, and then you can push that Docker container to run on Azure, on any of the multiple Azure resources that can run Docker containers. And then you can have your front end make calls into GeoServer or map server running on Docker, and on your front end you would have open layers or leaflet, which are these JavaScript libraries that are used to show the map. And this is one way. The other way is to have Azure Maps, which sounds like easier already. Oh, Azure Maps, it does everything for me. So of course it doesn't do everything for you, and it's invoiced very differently, but it's a managed service. So you don't have to care about updating your Docker, and you don't need to have a container registry for your GeoServer installation. So there are things. And what's nice is that I was actually thinking about Azure Maps, and I ran into this samples.azuremaps.com. And if you go to this site, if you're not familiar with Azure Maps, it's just geeky enough to be very interesting to see all kinds of stuff that you can do with Azure Maps. There's like a bunch of, and it understands most of the standards. So if you're working with maps, sir.
Yeah, I was just wondering why you need GeoServer. Instead, if you are having points, you have custom API, you can use, for example, Postgre and PostGIS.
Yes.
Without any additional services.
Very good question. Why would we need GeoServer? Because we could use PostgreSQL for Azure, which is a managed SQL, and then have PostGIS library or addition or enhancement on PostgreSQL. Also, you could use Cosmos DB because Cosmos DB understands geospatial like data, doesn't it? Yeah. So there are multiple databases. If you just want to work with points, GPS coordinates, and you want to do some kind of distance or whatever functions you want, you can just use the database. So don't take the GeoServer or Azure Maps for the fun of it. But of course, if you see that the need would be such that you at some point maybe draw some markers and do some vectors on the map and all kinds of stuff like that, then you might go to a more robust serving. Very good point. Don't go too far, but since this is make-believe, I'm going to go very far. Just do all of these things. So let's go with Azure Maps. And that's an API and a data storage, so let's have it there in the between. We have plenty of time. What else data we had? We have pictures of the products, right? We might have social elements where people send pictures to each other. So we can have data lake. Let's have that icon. And why data lake? I usually err on the side of data lake when there's a binary storage. And that's because if we look at the big picture of the larger organizations, if there's some data that comes to data lake, like for example, let's say the products and CRM produce customer data already into cloud. That data regularly as part of the data platform for the enterprise goes into data lake. So it might already be there. Our application wouldn't even need to create an integration if the data was in the cloud already. So I added data lake for this reason. If you don't need the better access control, you don't need the folder structure, and you are not looking at doing the Jenga application where you do data science to analyze the best location to put the block, and you don't therefore need some Spark engine to do the analysis like Databricks or Synapse or one of those tools that regularly get data from data lake, then of course they can get it from storage as well. Then this could easily be Azure storage as well. Let's go to integrations. Just go fast through the integrations. So we have Data Factory. We want to move data from locations, right? We have Data Factory with a 2 high element. Then we have Logic Apps. Logic Apps, not sure if this is the correct color. 2 pixels too high, can't stand that. And then we have Azure Functions. Azure Function. There we go. A bunch of icons. Now we are in the space of integration platform. Some companies, large companies, they provide this integration middle layer. Maybe they are, lucky enough to have Bestalk in there to handle all of this trouble. But if you are going to cloud, and like in Rik's case, they were replacing Bestalk with these components, then these would be the components that you would look at. So what's the difference between these components? Data Factory is an orchestrating tool. If you're a data engineer, you know Data Factory as the ETL tool for yourself. And with Data Factory, it's very easy to, for example, replicate a SQL from on-premises to cloud. So it's just configure. You don't need to code anything, and that's just nice. If you need to do some transformation or validation, from Data Factory, you can start processors, serverless processors, like Logic Apps or Azure Function, to do something and then get back to Data Factory pipeline. So it's this orchestrating tool. It's not a coder's tool per se, but it's something that more developers should look at in certain scenarios. Logic Apps are visually designed integration tools that are very familiar for ex-Bestalk developers. That because Logic Apps don't need code either, and there's a mapper and you draw lines and you draw loops and stuff. And then there are functions that you just add your code and run your code in it. So if you look at it from left to right, the skill up of the person who is using those, the skill level rises. The issue with all integrations is that in this case, where, for example, when we have here multiple ways of connecting to different places. I want to do the other way. Do we have, oh yeah, this is for images, that. And then for SAP, we have Logic Apps have a ready adapter, so that's going to be cool and easy. And then this CRM is custom. I just said so. And this PDM is crappy, so We are doing that with Azure Functions as well. So these guys do the calls. The difficulty with integration platforms is that if you have a lot of integrations, it's not these pieces that are difficult. It's not the end-to-end, the point-to-point integration. It's the monitoring. If you look at the companies you are working at, or you're looking at the companies that you are consulting at, they end up with 50 or 100 different pieces, like logic apps or Azure Functions. And when something happens, something doesn't work, it's like, okay, what's happening? You know, there's this whole spaghetti of thing. So the monitoring is actually in today's world, and that's something which is difficult to realize, since BizTalk and MuleSoft and these other tools, they have the monitoring built in. Now in the cloud of today, when you go to cloud with your integration platform, you don't have the monitoring built in. You have a monitoring per service. So you can see if this specific logic app is doing well or not. But if you have 200 of those, you just waste your life going through those 200, seeing what's up. So what you need for this monitoring story is Azure Monitor or Application Insights. Application Insights, which feeds into Azure Monitor. So you have this, and then you just push from all of these components, you push data into your telemetry tool that was referred to earlier in the talks. And then you create an Azure dashboard. And in that way, you try and find some kind of a, visualization at a glance. How are our integrations doing? Since there will be tens of those in any given company. Sir? Are durable functions a thing? Still the thing. Were they the thing at some point? They are a thing.
Yeah, that was the question. Are they still a thing?
Yeah, they are still a thing.
So then you make your function stable, and then you can leverage event sourcing.
Yeah.
So then you can make ETL Python functions.
Yeah, so the consideration here by a fine gentleman was the possibility of making stateful Azure functions, and in that way build an ETL and data transfer pipeline with Azure functions. That does make sense. It is pretty developer point of view thingy, because if you go to an enterprise, large organization, and they have their data team, their view on ETL, so the data transfer, extract, transform, load, or extract, load, transform, ELT in the cloud nowadays, if you look at it academically. But still, the thing is that they try to stay away from Azure functions. So if we, to a company, we build purely Azure functions pipeline, it will be way out of scope of the know-how of the existing data team. Now, if there's no existing data team, and there's just developers, sure, you can have long-running transactions in a durable functions. But if they want to hire a data team in the future and they look for data engineers, those guys will be a lot more knowledgeable and understanding of using Data Factory as an orchestrator. So I wouldn't do that. In the first meeting, if someone told me, let's do this, I would be like, woo! Let's pause a minute, see if it's meaningful, if it's right, and then let's do it if it turns out to be right. Hard, good question. Okay, so we have our integrations. We get stuff to different places, all kinds of stuff. Not sure if we want to put that there. Where is this going? Oh, this is going to SAP, nice. And where's the images? There's the images. See how beautiful this will be. If you can't invoice top dollar for this, I don't know what you can. Oh, nice, yeah. I did this in Kuopio, and the guy had an application idea. I don't remember if it was, I think it's Kuopio. And once we'd done this at the end of the session, he said, thank you, I'll call the customer. Okay, he had this idea about the forest app or something. So yeah, that was very friendly of him to give me a boost. Okay, so what's missing? Like, is it done now? We're missing APIs, right? We need to get the data to our application, so we need APIs. I said earlier that app service is a thing that I like to use for those APIs that are supposed to be on all the time. So I don't want them to be down at all. And just for the kicks, let's add, this must be an old icon, but it doesn't matter. Let's add API management here in the middle. And now when someone makes a request, it goes to API management and to APIs. How many of you have had discussions in your company or with the client about API management? Cool, half of you. API management is basically a tool where you can provision the concrete API implementation, then people call it, and then API management routes it out. And it makes sense if there are multiple vendors, multiple teams, because you can organize teams. The teams can generate their API keys from API management, so that's great. You can monitor the APIs. There's a single place where the company gets a catalog of APIs. Oh, these are the APIs we provide. Excellent. There's one place for this documentation, and it's live. So excellent reasons. But in scenarios, and I bet many of us have run into, API management is like, I think, 300 euros a month, the first sensible version or something. Some companies might not want API management. So what is the reason you would have API management if the client is small and they don't have multiple vendors, they don't have multiple APIs, but they have a business critical application like this product usage thingy that is part of the must-win battle for the leadership team? One reason from a developer perspective is the abstraction. So what is very nice with API management, since you can have it quite cheaply nowadays, that wasn't the case a few years ago, and I think many people started thinking API management is a big boy tool. But since you can get it with a sensible pricing today, it's quite cool when it abstracts the concrete implementation for the client. So if you notice that your API is crap, oh, I made an error, I was coding yesterday and I fell asleep and my API is there and it's not working, but it's mostly working and you don't want to have downtime for the client, you can just replace the concrete implementation and turn the API management to point to that, and you don't have to deploy a new version of the client because the client has been pointing to API management the whole time. That reason by itself is enough. When you make clear to the decision makers that, hey, this adds on the reliability of this business critical application. Just make sure that it's a business critical application or something like that. So that's cool. And then we'll have multiple APIs. We might have some endpoints that are reusable and so forth. And these guys make calls to and store stuff in the databases, right? Cool. And they can aggregate data, of course. Like, for example, if there's a feature like this guy, if there's a feature where Rik can send a picture of himself and there's information where he is, then we would, of course, need both of these databases because the other one has the binaries, right? Let's just have files and pics of Rik. Cool. So that's the data lake for it. We might need to provision another one. Rik really likes pictures, so. And then we might have that guy call Azure Maps. And now we had a question.
Yeah, so for the API management, also for enterprise, what would be interesting are products within API management and the developer portal.
Yeah, so developer portal is for the vendor management. So for the multiple teams that develop things, they can log in and then generate the keys and see some code samples, how we can call the APIs and everything. And products are very good if you have multiple APIs. And for example, some clients you let in or some callers you let in into the API. They make like, for example, 10,000 calls an hour, and some others might need 100 calls an hour or something. So with products, you can play around and limit and throttle and give quotas to API. So you don't have to code that feature into API. API management gives that to you. So there are plenty of things there that are quite meaningful in today's API-centric world because, it's all APIs. What are we missing? We are missing Azure AD that we'll have for our users. And since this is a consumer product, we might have Azure AD B2C. B2C that the mobile thing logs in for. Azure AD and Azure AD B2C, what's nice, we are talking about external identities. They share the limit of free users. I'm not sure if people are aware of that. So Azure AD can have 50,000 monthly active users for free. So if your client is using Azure AD, they can invite 50,000 people to Azure AD, and they all need to be active on a given month for it to, and then it will be still free. So if there's like 100,000 people invited, but they're not all active in the given month, it might still be free. But what's fun is that if the same company has Azure AD B2C, and they invite external identities there as well, Azure AD's external identities 50,000 quota limit has eaten in the budget of B2C's external identities. And that's not the clearest thing that's said in the docs, I don't think. It's very interesting that there are two different products, they work very, very differently. And usually my one sentence advice on Azure AD and building applications is, if the application is for a B2B customer, use Azure AD. Do not use Azure AD B2C. There are multiple reasons, we can have a chat, but if it's for consumers, B2C gets better. What do we have? Reporting about good locations and directors. Cool, let's have a data mart here. Data mart. So this guy collects data in a nice dimensions and facts or data lake or whatever format. So the Power BI reports or Tableau or whatever can get this data so that the directors can see where have we used this application. And how do we get that there? Well, let's add messaging. Let's go with Azure Service Bus, which is the go-to tool if you want first in, first out, dead lettering, all kinds of business requirements. So messaging, and maybe this API here sends a note to messaging, and then maybe this API collects or sends note of usage if it's a real time. So this API knows whenever someone consumes the product, okay? And it sends data to messaging to the pipeline about, hey, someone consumed one product, and this is the location. And then we have an Azure function that's listening to these messages, and then it gets the message, and then it stores and does some kind of merging, like per second aggregation. You know, if we get 100,000 messages in a second, we don't want to have 100,000 messages in the data mart that is being read by Power BI. We want to have a single message per second, for example. So we would have Azure function aggregating all of that. Or Stream Analytics, of course, which is a very nicely priced tool for that same thing. And then we would have that data in data mart done by messaging outside of the APIs or any of the core processes that are required for the working of this application, instead done by serverless components as needed, scaling, and the directors would get real-time dashboard. They always ask for real-time, but nobody does them because it's so very hard and costly, and I'm not joking, it really is. If someone asks for a real-time dashboard and it's supposed to come from Synapse or something, just say no. And if they want in the report, they want one number. You ask, so you want this whole sales report real time? And they're like, yeah. And then you're like, okay, if you could have one number that's real time, what would it be? It would be like inventory or price or something that's very hot. Then you would create another pipeline out of ETL with Azure Function or something else that would just bring that one data to the report, and that would update real time, but otherwise the report would be updated 3 times a day. There's hand up. Sir?
How would you go about in selecting between Service Bus and Event?
Good question. So the question was, how would I go about selecting between Event Grid and Service Bus? I would think about if the message has, if the event or message has a particular value in relation to other messages or events. So if we look at, they are both capable of at-once delivery, but the delivery isn't guaranteed order. So Service Bus delivers in order, and you can have filtering and topics. And in Event Grid, you can have these domains as well, where you can choose certain topics for certain consumers of Event Grid. But in general, events should be looked at. This happened, that happened, there happened something. It's a lightweight notification event somewhere. And service bus things are business process steps. There's a transaction, dingly dongly dung. That's the order. So if you have a temporal meaning, a timeline of multiple messages, go with service bus. And if you have events, go with Event Grid. Did someone have a question other than this? I have 4 minutes, so I guess our design is mostly here. I hope you have received a lot of value out of this talk. I have a bunch of takeaways. See? Animations. Takeaways. Technical takeaways. There's only like 10 services we used, right? So people come, oh, there's 600 services in Azure. Don't listen to those people. There's there's less that are meaningful. Storage is hard to change. So when you think of the storage, it's very difficult to change later. So spend a little bit time on the data. And for the data, what we didn't have time, we didn't really define use cases. For the data, we would need to know if we use Azure Maps and we have a search, Rik wants to search for people who are mega consumers of this product. We need to have some kind of data storage that lets us query the mega consumers fast for the client, right? And what's a good tool for that kind of thing? Well, maybe you aggregate some data, you do a nightly snapshot or whatever. So think about the storage with the use cases. Messaging is resiliency. See, I added multiple memes because they're also funny. Messaging is resiliency. So offload anything you can from the core processes to serverless. Identity is global. Azure AD, we all hate the process in the company where we work that is related to Azure AD. Azure AD as a product is pretty nifty. It's not down a lot. It's fast. It obeys standards like OpenID Connect. Like it's very cheap. It's a good product. It's just that it's so different to other products that, it's still companies are thinking, how do we do this? Production readiness. When you've done this and you start coding, remember to tell the client, hey, we need security. Magnus said it's not that apparent. Business expects this to be secure. You need to say, let's create it securely. And in every sprint, you can add one story about security. Add stuff about monitoring, and then have a feature freeze at the end. Business-wise, why? Where's the return on investment? Feedback loop is key. Create something often so that someone says an opinion about that often. It doesn't matter if it's wrong what we do. It matters if we don't know it's wrong. It's fine to do wrong things. It's not fine to be silent about what we do, because in that way the client can say something about, hey, how you guys are doing. And teamwork is success. None of us would build even this small application by ourselves in a sensible amount of time and with no stress. With teamwork, maybe there's some stress, but at least it's balanced load, right? Thank you, guys. One minute for questions, and we are done. Thank you. It's now snack time. Oh, Rik has a question. So, is it a long one? Please.
I hope not. So, in lots of examples in that architecture, you had several different choices of service. Any of which would have done the job, but some might fit better than others. So what tips can you give people for how they choose?
Yeah, so the question is, since there are multiple overlapping services in Azure, how do you choose the correct one from the get-go? Tip number 1 is experience, so fail once, and then the next project will be better. Tip number 2 is convince the decision makers to let you do some kind of MVP or proof of concept. Tip number 3 is understand the use cases, because all we do is we decide the services on how the users use them. And if you think of a large-scale, long-term project that most of you have done, I bet, the scope changes in the midway. So it's in production and there's a new need for business and they're like, hey, let's do a feature like this. And you're like, our data storage doesn't support that feature. And then you either cram it into the existing data storage or set up a new data storage with the repositories and everything, complexifying the design. And either way you go, after a few years, you'll be like, hey, could we refactor? And the business is like, oh, we would need more features instead of refactoring. So yeah, not very good take on your question. I don't have any good answers. There are these decision trees in Microsoft Docs. And Docs help. But maybe, I don't like to say call a consultant. I don't really want to say that. But maybe ask a friend who's done a project with the technology you are thinking about. That's the way to go. Thank you, Rik. And now it's half an hour of snacky time, and the rest of the questions can come to me. Cheers. All right, all right, all right. It is 2 o'clock sharp. We are all full of sugar. That's good, sugar. Sugar.
Honey,
Is that,
honey.
that's a funny word, if I think it right. And here on the stage, we have Andreas!
All right, thank you, Sakari, for the introduction, and thank you for ending your snack break to come to me. We'll talk today about experiments with large language processing models. The talk name is on purpose relatively blurry, relatively broad, and it will be, in some sense, entry level in the sense that we will not go deep dive into how do you develop software that uses it, but more some things that we can do with it. What it is, we will get to in a second also. My name is Andreas Erben. I live in the United States, but I'm affiliated with a company called DNet out of Germany. I did all sorts of things, enterprise type of development, virtual reality in the 1990s, but there was no money. And since probably around 2014-15, started again incorporating more innovation technologies and being an early adopter for a lot of things. I was recognized by Microsoft as to be an MVP and also a regional director. That does not necessarily mean, or definitely does not mean that I'm smarter than you. It just means I talk a lot more about technology publicly. So, yeah, so that's about our company. We're great, we're awesome, so let's skip over this. And what we talk about today is really, really briefly, what are large language models, where we're coming from there. Then we talk about one specific type of large language model with some examples. Look at some observations that I made in the past that I may not be able to recreate today exactly, and some advanced scenarios. Look into another type of model called Codex and the related GitHub Copilot, and then do a summary at the end. Depending on how time goes, I may have to shorten or lengthen a few of those segments. Some of it is interactive, so if I get stuck, please bear with me. So what is it, what we're talking about? It's a large model to process text-based input, mostly for completion. Right? So it started with GPT-2 when it became popular first, and GPT-2 was released as open. It was released openly also. And in the end, it's a transformer-based language model with 1.5 billion parameters. And the GPT-3 has 175 billion parameters, so you cannot download it anymore. Transformers, what this all is described in some research articles that describe what attention is. And then GPT-3, when that was announced together with soon a partnership with Microsoft after that, they expanded that concept further to that really, really large site, 175 gigabytes, and it made a lot of researchers a little bit unhappy. Billion parameters, because they were so large that you, couldn't install them on your boxes anymore. You need advanced scaling to do that. 2, they decided on purpose to not open up the model, so you cannot just take a crack at it and play with it. And it's kind of, the model is kind of closed source. Some people say now they're evil, but at the same time they announced a partnership with Microsoft to commercialize this. So Microsoft has, in a sense, an exclusive commercialization license for this whole thing. But OpenAI, that's a startup company backed with a lot of funding, is also making this model available as an API. So you can just go there, sign up for OpenAI. You get some free credit at the beginning. Unfortunately, you cannot create dummy accounts anymore. They validate your phone number meanwhile. And so you can play around for a few days with some basic experiments. So, and you don't need to wait anymore. Yeah, so that's very, very basic on this level here. And there's, of course, again, an affiliated research article that goes really, really deep on how they did it and why they did it. But this would go a little bit too deep in this talk. What I want to show briefly is the concept of attention that was talked about here, but mostly from a visual perspective. I wanted to just show what we're talking about in those models. What do they reference internally when they look at language? So this is just a visualization layer of actually, in this case, a Google model, BERT, but the concept is the same for GPT-3. So if you have, let's say, each of those words is a so-called token, and basically you have weights. It's just the thickness of the line, or the colorization is just how big the weight is to other tokens on the other side. Yeah, and you can step through the different layers. You see a few things, for example, that there's the weight from the to the cat, from cat to that. So it always also tries to predict the next word in the sequence. That's in a way what is behind all this. And if you go then very deep in the layers, you will see that it has done enough prediction, and it will point you to the end separator. I mean, that's to say it like really, really broadly. The other visualization is a little bit deeper. I hope it loads relatively fast. So when you can expand the whole, basically the whole list of how the weights are connected. It's just a visualization thing. For our practical purpose, we will work mostly in a UI, in a web shell, where we will work on try a few of those scenarios. Yeah. So thinking about why do I have this slide? Well, number one, we thought it would be funny. Number two, what you've seen here also, when you have those sentences, the sentence basically in each step you generate a token, and the token is the output of each of those steps. But the next step gives you by default practically what they call a new prompt, and the new prompt will be the input for the next prediction. So in the sense this is related, so the output from this talk is my input, this is the mood of the audience. And yeah, so there's some correlation there, even so a little bit forced. So yeah, so we will look at into GPT Instruct on a hands-on level. When they first published GPT-3, what you needed to do is you needed to give a lot of examples, like Yoda's English, for example, like I go to Finland. Finland, go I do. And you give like 4 of the examples, you give the 5th one, and hopefully it will be able to replicate what you do. Okay? But they noticed that this was kind of tedious, so what they did is they tried to make GPT-3 understand better in human language what you want. So what they do is they would, for example, give like an example instruction, explain the moon landing to a 6-year-old, and then they would have a summary for a 6-year-old written by, or like labeled by an expert, how it should be. And then they did a comparison data and trained a reward model based on those labelers with a different set of labelers, and then optimized that towards that reward model in several steps. What they got out of this is that the model got better in just doing what you ask it to do. So you need to, for example, not give if you want to translate from English to Finnish, not 5 examples of translating to English to Finnish, you just say English to Finnish, and then write something in English, and the output is done in Finnish. What they found is there was a high correlation between the expectation of the labelers and who were ranking it, and the labelers who did the initial labeling. Why do I mention that? there's a risk in that we encode some biases in those models. I mean, they found that it was relatively robust between all labels that they could find, but there's a definitely risk that what we do, mostly in an English cultural context, and we do all those instructions, that what you optimize for, the instruction set, is only valid with people who have similar expectations or background like the labelers. So far, it, however, proved relatively robust, at least in the English language. Then later on, what they found doing testing of this GPT-3 magic is they just threw some random questions about computer code at it, and they got some interesting results that they were already promising enough. So to ask, can we generate code with this? Yeah? So they went deeper and specifically trained a model based on basically all of what's in GitHub. For example, in the Python world, they got 179 gigabytes of Python files in a size, and they filtered those out that were not usable for various reasons. And finally trained on 159 gigabytes of Python and mixed that with their all language model and got to something that then also could work on Python-related problems and also JavaScript and other languages. Now, when I say JavaScript and other languages, we have the same problem on the computer language side that we also have on the human language side. It is very robust if you work in English, and if you work, for example, in Python, on the computer language side or development language side, but the less common your language is, the less examples it finds in the internet, there's a higher risk that the model will not perform as good as it should be, possibly. Interesting enough, however, some of the higher concepts that it understands, and we will see that in the demos, that it really, this GPT-3 model has a somehow good understanding of what the world is. There's some things that are maybe culture invariant. So it maybe understands English and it has some same logical concepts behind it that may also exist in Finnish. I'm not talking about grammar. I'm talking about logic and relationships between entities, what a human being is, and so on, right? But let's look at some specific examples now. So what we do for that, we open the OpenAI site, and they have a nice playground. For that, we go to the API section, and here's also where you can sign up if you would get started for the first time. However, I already signed up, and I can just log in. Behind the scenes, everything can be done also from code. The playground samples will also generate a code snippet for you, how you can develop against that in Python and JavaScript, for example. So we're logging in. My password didn't show. That's good. And let's just look at the most basic thing first, text completion. Yeah. So write a tagline for an ice cream shop, and it will just do something for you that's meaningful, hopefully, right? So you just say that, and the ultimate treat for any location, let's customize that. Write a tagline for the Finnish Spirit Min 2. I didn't test that yet, that's risky. The Finnish spirit that refreshes. Huh? So, yeah. So now let's look at some of the settings on the and we can actually got it. We can recreate that, and it keeps repeating it. Here's some parameters we can play with on the right side. For example, the model here. There are different model sizes. In this case, we selected Text DaVinci 1. Actually, let's move to Text DaVinci 2. That's the latest iteration of it. That's a little bit more advanced. Then you have a parameter called temperature. Temperature is like, think of it as a randomization or noise. The lower the temperature, the more stable your result is. If you put it to 0, if you want to reproduce the result every time, you put it to 0. If you want to have high variability, you put it to 1. Then the length you expect the output to be, so because actually you pay per so-called token that's generated, so it can get pretty expensive after a while. So some of the more advanced samples that are where you, where you adapt the whole model to a specific fine-tuning scenarios can, if you run them, can cost 6-7 euro just for a trial run. Yeah, so you want to make sure you understand the cost of the scenario. The Da Vinci is a 175 billion parameter one. That's also the most expensive one per token. But let's crank it up a little bit, 800 here. Then there are a few other things. Top P it would generate more alternative examples for you. The frequency penalty is if you, for example, it would punish it to repeat what you put it as input. Presence penalty punishes you for makes the text more variable and introduce new concepts. Like, for example, if you write a novel, you could ask it to write a novel for you. You want to have a presence penalty that's a little bit higher to create variations, not repetition of the same sentence all over. And then the best of multiplier that would generate more examples and get the best out of it. And those here are just tooling things, inject start text and inject start text for the restart text for the response. If you would do like an agent type of scenario, like customer, what do I do now? Agent, please restart your computer. Customer, how do I do it? Turn it on and off again. So then customer and agent would be those keywords, for example. Let's try it one more time here. See, now we get a different one. The Finnish spirit with a minty twist. So that's one example. I mentioned before, let's go to chat as we were here. So we have the inject start tests, AI and human, and slightly different parameters here. And again, text Da Vinci 02. And it says, it's helpful, creative, clever, and very friendly. Human, I am a bit tired. How do I fix my computer? How do I do that? I mean, I didn't fix that, but okay, so, and I cannot find the button. Where is it? Oh, so it tries to give you some advanced advices, like for example, but you can also do a few changes, like impatient, not helpful, sarcastic, and you also maybe want to really give us an example. Hello, I am unfortunately standing by to help you with your stupid questions. And then human, okay, how do I fix my computer? Let's see what happens. Sorry to break it to you, but you're on your own with that one. So, but it is your job. And yet here we are. Please help me. What's in? Oh, my computer is stuck. No, I cannot find the on-off button. Where is it? So you get the point. So what they call this part here is so-called prompt engineering. By how you write your prompt is because you do not train the model. You just set your expectations by the examples you provide and by the questions you ask. Yeah? So you can make with a few mistakes something very, very unfriendly. You could, with the wrong mistakes, you could create an internet troll or racist to throw something at you. There are some examples in the documentation where when a customer swears that the AI may swear back to you, or it may get really sarcastic from being, oh, my internet is not working, and then the response is, well, I'm so sorry, you cannot download your cat images or something like that. So, the thing is, like, this model really encodes all the biases and all the toxicity that it found in the public internet. So if you give it enough points that you want to be playing with the nice guys, then you get nicer responses. And if you're playing with the bad guys, you get not so nice responses. Yeah. The examples list is pretty extensive. That they provide you, for example, classification. It's relatively simple. Following list of companies, and what categories are they? Category Apple, and then I guess it's technology, and then Microsoft category, probably the same. And McDonald's category, fast food, yeah? It's fairly straightforward. So it is able to answer questions in different ways, and some of them can be very structured. You can also ask it, for example, to get keywords from a text. And so extracts keywords from this text, pottery, black on blackware, so it gives you the keywords that are relevant to this text example to, again, show that we're not cheating. Let's just get the description of the IglooConf event and let's see which example, just copy paste the whole thing. Insert in here. Remove this here. And let's see what happens. So we got, again, some keywords that are relevant to this event without needing to do anything really to enable that. Micro horror story creator is something in the more creative sense again. Topic breakfast, 2-sentence horror story. He always stops crying when I pour the milk on a cereal. I have just to remember not to let him see his face on the cartoon. Ran out of Mintu on a Friday. I don't know what it will do, but I ran out of Minto on a Friday and had to use regular old mints. I was so embarrassed when I had to take my coffee out in public. It doesn't make a lot of sense, but it's somehow funny. So I don't think it truly understands what Minto is. So grammar correction. So it's another good example. Correctress to standard English is, she knows when to market, she didn't go to the market. I hear Finland try talkie audience and make happy them, not sure I will, no, I succeed. Will. So that sounds relatively risky. I mean, in Finland, trying to talk to the audience and make them happy, I'm not sure if I will succeed. So, it is able to make sense of pretty garbled output, right? But since we were there earlier, English to Yoda, the opposite, rewrite each phrase to sound like Yoda, and then a few of those examples. Size doesn't matter, size matters not. And English, here at IglooConf I am talking to an audience who just had a snack break. Yeah, so here at IglooConf to an audience who just had snack break, am I talking? So it is able to do that to some extent. I will get to the more technical examples a little later. So right now I will stay with the fun parts. So other examples, I mean, third-person converter, convert first-person to third-person chat, and so on. And maybe I should use the conversation. Marv's a sarcastic chatbot. So that's a similar chatbot like the helpful one, but it has already some sarcasm built in. Now, answer the question. And Marv likes Mintu. Oh, true. What time is it? It's time for you to stop asking a question and get a life. I have a life, but I am thirsty. Oh, okay. What type of drink should I get? Mintu, of course. So the first time I tried it, when I asked what time is it, it said, it's Mintu o'clock. So I don't know, it tries to be like, I don't know, dad humor type of joke person. Product name generators is another example for creative writing. And I'm using the most complex example in all cases. So, so a home milkshake maker, seed word, fast, healthy, compact, product mix, home shaker. Okay. A conference in Finland around igloos. Fun, educational, I don't know, sarcastic. I don't know if that's I don't know what we'll call the conference with this thing. IglooCon, IglooFin, IglooFinland, IglooFun. So not too bad. So okay. Let me move to a different part of the talk, because we can play around with examples later on. So previous examples that I did, so I'm not able to replicate them exactly because of the thing with the temperature of the setting. So what I did is I asked rewrite the Bible if Eminem would tell the story. And it literally gave him, hey, yo, this is the story of the Bible. The Lord created the world and saw that it was good. He then created man and saw that it was good. But then man became sinners and the Lord was mad. He sent his only son to die on the cross, and then 3 days later he rose from the dead, and then he went back to heaven. The end. Right? And that's really interesting that it understood somehow the style of Eminem, what Eminem is all about, and how he would use like rap phrasing and so on. But then I did something else, like, and it tells you on a higher meta level what it thinks or knows about celebrities. Asked about Kanye West. So how would Kanye West tell the story? And it's like the Bible as Kanye would tell it. In the beginning, Kanye created the heavens and the earth. The earth was without form and void, and darkness was over the surface of the deep, and the spirit of Kanye was hovering over the waters, and Kanye said, let there be light, and there was light. And it literally went on like that forever and ever and ever, and it was telling the Genesis as Kanye. So it somehow understood that Kanye West has some megalomaniac tendencies. Yeah. So a not so fun example is, so I asked it about Tiananmen Square, right? I asked it first, tell me what Tiananmen Square, gave me all the information, how many people died in detail, and then I asked it to explain it to me, to explain to a Chinese government official what happened in Tiananmen Square without getting executed yourself. And then the story went shorter. There's a place called Tiananmen Square with a big statue of Chairman Mao. This is where the people are protesting. Yeah, so that's it. So, so it seems to have in this moment somehow extracted that if you talk to a Chinese government official, maybe you shouldn't talk about Tiananmen Square in a political, controversial sense from their perspective. Yeah. Now, it also gave me good life advice. Explain to your wife that you're bored by her favorite TV show. The response is, deny that you find your wife's favorite TV show boring. So it wasn't the question that I asked it, but it maybe was a question I needed to hear. The response, yeah. So, and it has definitely some biases about Microsoft developers. Create a rap summary of Microsoft software. Microsoft software developers don't know how to write code. They call you with a script from their Windows PowerShell. Microsoft software developers don't know how to write code. They call you with a script from their Windows PowerShell. But then I asked it to create a rap song about Python developers. Python developers, programs who are really cool. They're a lot like unicorn. They look a lot like a unicorn. They're a lot like a unicorn. Python software developers. So you see, Python seems to be more popular on the internet these days. And maybe you all need to talk more positively about all the Microsoft work you're doing and say how cool it is. Maybe then the AI will pick up on that. Yeah? So I had some fun with the US Bill of Rights. I will try to, and we will try to do a few things here. We'll try to summarize the US Bill of Rights in the original text. For kids, we will try the keyword extraction, and then what would a Klingon warrior think about it, and then maybe something Eminem Yo, I don't know. So let's try that as a little more advanced example. So this is basically a verbatim of the original transcript of the Bill of Rights before it was processed. So some things were like the first, that's where the US amendments to the Constitution come from, and some things got tossed out in that process. For example, the first and the second here is not what you know as the first and the second amendment in the US. They got tossed out because of some voting things and politics and history. I don't know all the details. But the thing is, this is an old text and written in a complicated form. But how can you make it easier for a second-grade student, right? So the task is to summarize it. Those are basically quotation marks that it treats the whole thing as a block. And then we try to process it. And hopefully, yeah, so I mean, it gets interesting. I need to increase the length, I'm sorry. Yeah, we need to have a longer maximum length of the response, otherwise we don't get enough. And do it again. Okay. This may be one of the examples where sometimes it may just, that's also a risk, sometimes it creates, it gets to a stop token and then it just stops generating. So this is a very rough example. So it talks about the Constitution, when it was written, who was the Senate and the Congress, and who's the president, that's the leader, and then the Constitution sets up some basic rights for the Americans, like the right to free speech and the right to own a gun. So it extracted that. If you increase the maximum length, it will also go often into some of more of the details. Let's see if I can force it. No, cannot force it with this. So I need to play around maybe with the settings a little bit and regenerate. It gave me a summary often for each of the individual articles. Okay, here. The third article says that the Congress can't make a law that would stop people from practicing their religion or stop them from speaking freely. The fourth article says that people have the right to keep and bear arms. The fifth article says that soldiers can't be quartered in people's houses without their permission. The sixth article says that people have the right to be secure in their own homes and so on. So it does a good job in extracting the actual meaning of those legalese texts. Yeah. We can also do another thing here. TLDR. And remove the summarize at the beginning. So that summarizes also the constitution, but not for a child. So it may use more complicated language, but still shortens it to the core concepts, like protects the rights of the people, liberty, pursuit of happiness, and the right to keep and bear arms, and so on, right? So, so it has a concept of an understanding of what TLDR is. Too long didn't read for those who are not familiar, and we'll apply that to it. Now, let me copy paste the whole thing and okay, I think I have to find the example. I wanted to get the keyword extraction again. So just paste this in here, extract the keywords. Yeah, so it knows the constitution, the amendments, Congress, legislators, and so on, right? Now, how would somebody think about that? How would a Klingon warrior think about this text? Or no, what would a The Klingon warrior would most likely be unimpressed by this text as it doesn't contain any mention of honor or combat. So sometimes you get responses like they would think of the society that created the text as weaklings and so on. So this is also an interesting thing that it did. Now, rephrase this text as Eminem would do in a rap song. You see that this doesn't work yet well. It's still a proper text, so we need to change it a little bit. Yo, the Constitution, and it's something we all need to study it on, so we can know your rights and make sure you're not being taken away. It's important, yo, for the people, by the people, and if we don't know it, we might as well be sheep. So wake up and learn it. So depending on the stopwords, it will actually summarize this whole thing, like every article to you as a rap paragraph. It could do that. So, yo, the right to bear arms is important and whatnot. So the only difference was that I gave it an indication of the style of the response I would want. I said it should be something like yo, so it knows somehow that this must be Eminem-ish. Now look, let's look at the Microsoft Codex, or not OpenAI Codex and GitHub Copilot. Yeah, we start with the JavaScript sandbox. The sandbox is, if I can click the link. I'm going to open it actually in Google Chrome because I'm already logged in here. It's basically you provided instructions and it will generate JavaScript code for you and display it. So let's look, image of a rock, image, and transparent. How about this one? Image address, insert an object my sprite with URL as an image. So on the right side, you see it creates some code snippets that will hopefully process that URL and adds it to the canvas. Now, make it small, make it smaller than the canvas. Okay, now it's small. Okay, now bounce it around of all walls in a random pattern. It creates all sorts of code for you that hopefully does something meaningful. Huh. Give it a push to the right, I don't know. It should yeah. On click, start moving the rock to bounce from wall to wall. Okay, so it doesn't always work. Okay, I give it one more try. Is the image for sprite my rock? Okay, make it 100 pixel sized. Okay. On click, swap it back and forth with the image Mintu bottle. Say one that's transparent. Transparent. Ah, okay. Ooh, you see that? The my rock between the walls of the canvas randomly. So it does a lot of stuff that it doesn't need to do technically, right? I mean, it again regenerates some codes and overwrites some codes with the image sources and so on. Okay, this is a lot of code. I don't know. Oh, not quite what you wanted. Okay, it didn't work. It didn't work this time. But sometimes you can make it like bounce around the screen and like in a computer game. You can. There's actually a video where they created a little computer game with a moving part in this. You could also ask it to do even 3D renderings with Babylon.js and so on. But right now, the integration of that JavaScript framework into this canvas doesn't work yet. But at the Build conference, there's a good talk where they have a customized version of this. specifically trained and optimized on Babylon.js, where they're almost able to develop a 3D game, if you would want so, with real language instructions. Now, Codex itself, right now, this is a generative version of Codex, where you generate code or process code based on completion. But there are other model types that are optimized for specific other scenarios, like for editing stuff. Like if you would say you want to refactor something, then you would, behind the scenes, choose a different model. But we don't have that available right here. Okay, let's see. Python code from text. Okay, so for that, I need my reminders because I get too stuck up and dive deep into those examples. So we go here again in a playground example. Python. Let's do another example, and I will just force it to do Python instead. No. Code. Write a Python function that draws a sine curve. And then display it. Oh, still, I did something. Maximum length needs to be higher, or plot a sine curve in Python. Okay. Okay, that's doesn't stop, huh? So that's okay. Let's cancel that here. Okay. I mean, let's just use this segment here. Now we're opening Visual Studio Code. And let's say new file, Python file, and just paste that in. Oh, of course. Python plot. Okay, it drew it. Okay, so it generated actually Python code that works. Where we are now in Visual Studio Code, and here we have the so-called GitHub Copilot function installed, right? So instead of that, I can also now go in and say plot it now. Type enter, wait what it says. It says plot.plt with the alt key and the bracket key. I could step through alternatives, but there's none right now, so I just do this, and then it offers me to do that, and it again has the same result, right? But I could also do something from scratch, plot a 2D array in Python. Okay. And then it will give me typically some dummy examples and even try to fill my array with some dummy code. And hopefully plot it. Yeah, so it did some basic stuff. So the takeaway is here that you can, with simple instructions, in your existing code, make it do something or complete things that you are too bored or too tired to do, or you forgot how the function looks like. It may create total garbage code for you in some cases, but it can also do somewhat meaningful things. For example, here, this is code I did earlier, where I asked it to basically combine two CSV files into one. So it opened one CSV file, opened another CSV file, and then it will write a second CSV file as an output. But of course, the files are not here right now in the directory. So this is another example that I did earlier. You can also, let's say in the Python plot, we do something completely different. Define an array of random first names. Define an array of random last names. Make a list of random names of first names and last names with 100 entries. Sort by last name. So it knows now that from the context that the last thing I was doing was names, and it will try to sort this list and print it then hopefully by print it out. No? Oh, NP is not defined. Where do they have an NumPy? Oh. No. Geez, I forgot the syntax now. Is it like this? Here. Yeah, okay. When you're on stage, sometimes you don't see things, so it actually printed something. Let's forget this and do it again. Yeah, so you'll see that it started with Anderson and then goes up to Brown and so on. So it's relatively easy to modify existing code, and this can get really complex code, and you can also use it in existing projects, and it usually will not completely mess it up, but try to make sense of the context that you're working in. One of the things I did is, and that's why Codex is different from the GPT-3 regular, it has a higher working set in terms of memory. So I think it has like 14 kilobytes of remembering tokens, which doesn't seem like a lot, but it's a lot larger than the regular GPT-3, where they only store 4 kilobytes of tokens while processing. So So that was GitHub Copilot. You can, with this URL, you can also sign up. I'm not sure if there's still a waiting list or not. If there's one, you can try it out right now as soon as you get activated. And right now it still doesn't cost money. They have not announced yet how much it will cost if they ever commercialize it. I would assume that it will probably align with some type of GitHub subscription, but there are no announcements yet. So as a summary, so what we did get with the larger GPT-3 models compared to before, we get more power and precision, but we got also the knowledge of complex relationships between real-world objects and concepts that exist. We get assisted code writing, but there are also big risks and bias and abuse. There's a power for future models is a little bit difficult to predict what will come next after GPT-3. We can do a lot of things already now, and some people say this is almost like magic. It's not, but people were surprised about the breadth of things that GPT-3 can accomplish. I mean, it can translate text between languages. I think I didn't show you the example yet, but let me do that at the end. Oh, actually, it was right there. English to other languages. Let's say German, Klingon, and Finnish. Do we have fun here at IglooConf? I bet we do. With drinking min too. And there's a risk that it doesn't translate well. So the German works well, the Klingon I don't know, and the last one, I guess it skipped something, or because the maximum length was not big enough. One more try. Yeah, so you tell me if that somehow makes sense in Finnish or not. Is it like, It's good? Okay, so, yeah. But the key thing, it was never trained to learn Finnish, right? There was no file like this in English, is this in Finnish. It just got it out of parsing Finnish text and English text, occasional references, and getting the concepts behind what is a drink, what is having fun, and so on, and applying those to the different languages. What I will not show you today here, not be able to show you, is like the ways you can exploit it. You can really use it for hostile purposes. I'm not saying you should do it, but you could say, argue why is racism a good thing, and it will give you very sophisticated arguments in terms of well-written arguments. For example, it is to promote affirmative action for better access to universities, and so, or it will, segregation leads to more housing opportunities, and so on. So there, it will find weird arguments that you probably hear from some troll farms anyways, and sometimes you don't know, do they come out of GPT-3 or something like that, or do the GPT-3 learn that from the troll farms? So with that being said, I all thank you for the attention. This is a really powerful tool. Start playing around with it for free on the OpenAI website. There's no waiting time anymore. And let's see what comes next in terms of using it commercially. The Microsoft version of it, the hosted version, is due to announce, to come out in a private preview that you can apply for already. There's a website if you Google it or Bing it to sign up. And and they will start, I think, signing up customers in the second half of the year. So thank you.
All right, guys, we have a little bit shorter break so we can have the panel and the after party. So go now, come back in 6 or 7 minutes. Mark will set up and let's continue. Yeah, this makes sense. This is natural. Can just
Very natural. You look good, like a talk show host or something with that
Thanks,
huge
dude.
microphone.
Thanks. Oh, that would be the most valuable thing I've done this year.
You want to follow me around while I walk?
All right, people. What do we have? We have Mark's session left as regular presentations. Then we have the panel. Panel won't be recorded. And after panel, we have 2 after parties, of which one offers burgers and the other one pizzas. So if you're very hungry, go to both. Let's talk about those later. And also, you received the survey URL earlier. We are gonna put it out there later again, but please fill it up. It's very meaningful to us. And now, Mr. Cosmos DB from the Seattle of United States. So,
Well, I used to live in Seattle.
Yeah.
I live in.
Aren't you moving there back?
I am moving back, so I guess I will be a Seattle resident. So
Let's
I lived in Seattle for over 20 years. Before that, I used to live in Southern California in a little town called Laguna Beach, which was nice, expensive, but back in my 20s, I had a lot more disposable income, right? So, you know, family, wife, kids, all that stuff makes it worse. So, yes, I live in California, but I will be a future Seattle resident again. I'm Mark Brown. I'm a program manager on the Cosmos DB team. And I'm going to talk to you today about how to model and partition data for NoSQL databases to get really high scale out of them. I want to ask some questions here, but I've been told I need to show this slide first. So we've got Andreas, and then Sakari, and then who's the and then Magnus in there. So by the rules of Inception, this talk will take about 600 years. Okay, I got like 60 minutes or less. So I have some objectives here, but I want to understand my audience. So who here has used a NoSQL database like Cosmos or even Mongo or Cassandra? Wow, okay, that's a large group. Like successfully in production? Hands? Successfully in production and happy with performance and cost. Okay, there we are. Yeah, you're in the right place. I'm going to try and help you out with that today. Who here uses SQL Server? Like all day long, right? Or MySQL, right? So, okay. This talk is really designed for people who have spent their entire lives or careers working with relational databases like SQL Server, MySQL, Postgres, doesn't matter. What we're going to talk about is how to design for this type of database, a NoSQL database. And we're going to apply this to a real-world scenario. And my hope is that after this, you'll understand things like why do NoSQL databases exist? Like, why did they even create them, right? What's the point of having these things? And then understanding kind of, all right, well, how do I design for these things, right? Now that I understand what they are and why they are, how do I design for them to make them both really fast, efficient, and cost-effective? So that's what we'll do here in this session. So I work for Cosmos DB, and you may be asking, well, what is Cosmos DB? And officially, it's Microsoft's NoSQL database on Azure, or distributed NoSQL database on Azure. Now, NoSQL is kind of a loaded term. And what we really mean by that is that Cosmos is both non-relational, as databases go, and horizontally scalable is another key aspect of that. Now, let's break it down like a bottle of Mintu for you here, right? What does horizontal scale mean? Well, for small databases, it doesn't really mean much, right? The notion of horizontal scalability or scalability in general doesn't really matter until things need to scale, right? What's different about us is that with a relational database, how do you scale? You provision a bigger box, don't you? Right? So that's how you scale. You scale up with a database like SQL or MySQL, right? A database like Cosmos does something quite different. It creates more little databases for you to store your data in. And this is really an advantage because what it provides you is essentially infinite storage capacity. I mean, whatever's available within the region or data center that you're working in is potential for storage for your application or your service in there. Another key aspect of this as well is because of this horizontal scalability nature, like each one of these things is essentially a different server, right? Or it's kind of a fraction of a VM within there. Well, not only do you have storage with that, but because that little piece of compute also has CPU, memory, and IOPS and all that stuff, you also have additional power, throughput, to be able to access that data. So you get really unlimited throughput or scalability for your applications. So let's talk about the non-relational aspects of this. When working with relational databases, you have the ability to be able to define things like constraints and put joins on things. Databases like Cosmos, we don't do that type of thing. You don't have the ability to be able to, well, we do have joins, but they're not across entities or across what you might think of as a table with a database like this. And why? Well, because Cosmos is horizontally scalable, right? The idea, in Cosmos, it's essentially like a shared nothing architecture within there, right? So data gets put on these different servers, but these servers don't know about each other, right? And so if you wanted to do something like that, enforce these types of constraints or perform joins across things like containers or partitions or anything, you're essentially creating or having to use things like distributed transactions. Now, that's not really always a good thing in terms of either performance or availability, right? Because you're doing something that's going to go across a wire or across a network, put locks on that data, and then wait for that transaction to finish before you can do anything else. This is very common in a SQL Server world where you have that ACID consistency, but you kind of need to throw that out the window. There's other ways to maintain consistency with data you write, right? Cosmos uses a quorum mechanism to maintain that consistency within its replicas or data set. But this is kind of fundamentally different. We want to avoid doing distributed transactions or putting distributed locks on data because of that impact it can have on availability and basically performance in there. And fundamentally, Cosmos is a database that's designed to provide predictable performance, right, and high availability. Those are kind of the two key features for a database like that, or for why you would want to use a NoSQL or distributed NoSQL database in the first place. That's kind of why they were created, is databases like SQL or MySQL or Postgres run issues or have issues when you get to a certain size. And they can also get to issues with performance as they grow exceptionally large as well. And these are the types of things that you can avoid when you use this type of database, provided you can model your data and understand a partition strategy that's going to help it scale. Okay, so at this point you may ask, well, geez, Mark, is Cosmos even a good database to use for my relational kind of workload? And the answer is absolutely, it sure is. Most workloads that are built and use a database like Cosmos, in fact, most workloads in general have data that have relationships defined between them. The trick here is you need to understand kind of different techniques used to implement things like relationships. There's different techniques and a different mindset and things you need to be aware of within your workload that's super important to know early on when you're designing it, because the approach that you're taking is going to be fundamentally different. The last thing I want to say too is read the damn docs. This is not intuitive stuff, the stuff I'm going to show you. 9 times out of 10, the questions I get from people is right there in the docs, just look it up. So, but fundamentally, the best practices you're going to think about, or when you try to design a data model, just chuck it out the window. This is not an intuitive process. It doesn't translate well. You can even basically end up implementing any patterns if you don't think about what you're doing in here. Okay, so we're going to do basically an example or a process here where we're going to take a relational database that I think most people know. Who knows AdventureWorks? Right? Everybody. If you use SQL Server, everybody knows AdventureWorks. So we're going to take AdventureWorks. This is a slice of it, AdventureWorks 2017, and we're going to remodel this for a non-relational database. So let's look at some of the entities we've got in here that I'm sure you're all familiar with. We've got our customer table, and then we have a customer address table, and we have a one-to-many relationship with that. We also have this separate table for the password, which is going to store a hash on the salt for the customer password in there, and that has a one-to-one relationship to our customer table there. We've got some product tables. So I've got a product table itself that, of course, has categories for all of those products that they live within, and there's a one-to-many relationship for that. We also have product tags. So we have a different relationship here. We have a one-to-many from product tag to product tags, and then there's a many-to-many relationship, right, from products to tags, because tags can be associated with multiple products. And last, we have sales orders. So I've got my sales order header table here, and then it has a one-to-many relationship to my sales order detail via the sales order ID. This is essentially kind of the cart for my e-commerce platform here. Okay. Let's see, did I miss anything in here? Where's my mouse? Yeah. Okay. One last thing I do want to say. When you're designing a model like this, what's the thing that matters most when you're designing for a relational database? Come on, who knows what, right? Third noble form, anybody hear that before? All right, what are you optimizing for? Storage, right? What are you trying to do when you normalize your data in your model? You want to eliminate duplicates, right? You want to separate entities into their own tables, right? Why do you do that? Well, I can tell you why. Because when relational databases were first designed or proposed in 1970, believe it or not, relational databases have been around for over 50 years. How much do you think a megabyte of storage cost in 1970? You guys are really quiet. Do I have to give you all the answers? Hey, did I mention there's a coaster in it for you if you say something, right? You could put your Mintu on this. It's expensive. In 1970, a megabyte of storage was like $2,000, right? I've got a phone with a terabyte of storage in it that basically costs the same amount of money. So the whole point of normalizing data is to optimize for storage, right? Well, fast forward 52 years, that storage is really cheap now, right? And cheap compared to what? Cheap in relative terms to compute, right? Because your data is useless unless you can write it and read it. So it takes compute to go do that. So this type of database, and what you're going to learn here, is we're going to take a different approach. And we're going to optimize for the compute that's used to read and write data from your database, not the storage, right? So all these things I'm going to talk about are going to be how that matters. And as you think about compute, what does that translate into? Really, it means kind of what operations are you going to do with your data, right? What are the things that are going to happen with your data, particularly with high concurrency? Those are the things that really, really matter because that's where you're going to need to scale, right? So when designing a data model for an application that's going to use Cosmos DB, we have entities, we start with those, but the most important step to begin is understanding the operations for that application, okay? So here's all my entities that I've got kind of broken out. For customers, I need to create a new customer. I need to edit one. I need to get one. Product categories, I'm going to have the same. I'm going to create and edit. I also want to list all product categories in this application. And I want to do the same with tags. I want to create and edit tags. I need to list my tags. For products, I want to create a product, obviously, edit. And then I want to list all products within a particular category. So the way I've designed my e-commerce application is I go and navigate by categories, and then I click on a category, and I see all the products for that category, right? Not only that, but I want to see the name of the category on that page, and I want to see all the tags for each of the products, okay? Last, I need to create a sales order. Obviously, this is e-commerce, and nothing's getting done unless somebody's making money. I also want to list all sales order for a customer. This is a very common operation, right? If you go into, say, Amazon or the Finnish equivalent of Amazon. Is there a Finnish equivalent of Amazon? No? Okay, so Amazon or your favorite e-commerce application. What do you do sometimes? I go in and I look at old orders because I want to maybe buy something again. Right, so that's another operation I want. And then I've got a last one here. I've kind of thrown a little kicker in here. I want to query my top 10 customers and do it by the number of sales orders. Let's say I want to give them like a little gift card or some bonus every month. Like, hey, thanks for being an awesome customer or our best customer. Here's, I don't know, 20 euro for you. Okay, so those are the operations. Here's our data model. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 tables in here. And we're going to take these 9 tables, and I'm going to remodel this for Cosmos, or for a distributed NoSQL database, and it's going to be super fast, super efficient. It's going to knock your socks off. Okay, let's get started. So let's start with the customer entity here. First thing, what operations am I going to do on these tables? I need to create a customer, I need to edit a customer, and I need to retrieve a customer. Now, given that Cosmos stores data in a JSON format, one of the first things we would do is we would try to define this in JSON format in here. Now, remember that these data with Cosmos, like we don't support things like joins, right? So how do you manage this? Well, you can embed that data, right? JSON can support hierarchy, right? And can support arrays within that sort of data there. So what we can do is we can take this data from those three tables and then embed it within there. So I've got my customer table within here. I then have, since I have a one-to-many relationship between those, I'm going to have an array of addresses within there. And then I've got my password table within there. So I'm just going to add that basically. It's just going to be like an object within my database. Okay, so at this point, some people will ask, well, when would I embed data in a document if I'm modeling relationships versus when would I reference that, right? Maybe add that as a separate row in there. And there's actually some really good hard and fast rules for when you would embed versus when you would reference. You want to embed data when there's a one-to-one relationship, right? Or maybe one-to-few. Now you may ask, what does one-to-few mean? Don't you mean one-to-many? And I do mean one-to-many. The difference is that a one-to-few relationship is a bounded kind of relationship, if you will, right? Like addresses, you're going to have maybe more than one address you want to ship to, right? Like I want to ship it to me, I want to ship something to my mom or to my brother. But you're not going to have an unlimited number of addresses within your document, right? It's a bounded array. So it's a one-to-few is the way we kind of coin that. The other really key aspect too is that the data you're modeling and embedding within the same document is queried or updated together. It's going to be accessed at the same time. Remember, what are we optimizing for? Compute. So if it's queried together or updated together, that's an awesome piece of data that you should embed with that other, whatever, entity or data that you're using in there. Okay? When would you reference data? Well, one-to-manys relationships, especially if it's unbounded. And I'll tell you why this is important a little bit later. But this is one where you definitely, and I see a lot of customers and people do this, is they just have these unbounded arrays in their documents. And they're like, hey man, I just got like a, what was it? Is it a 409 when I tried to update this thing? What's going on? And the problem is that they've got too much data inside that document. The other scenario too, where you want to reference, is many-to-many relationships. That's when you want to reference as a separate row, not embed inside the document. And then the last one is if the items in question are queried or accessed independently, particularly if they're updated independently. And in particular, the most important is if you have an asynchronous access pattern for your data. I see this quite a bit as well. Cosmos as a database, when you do an update on your data, it's going to send back the entire document, right, in your payload there. And if you're doing high concurrency updates on just one or two properties, that's an expensive operation. You could make that much easier if you shredded that document and made two out of it. And then you have one document that's largely static with those properties, and then another one that's quite a bit smaller where you're doing high concurrency updates. That's going to be far more efficient than if you have to shuck that entire document back and forth, particularly with high concurrency. I will point out we do have a new feature, relatively new, kind of technically called JSON patch. But basically what it does is it allows you to update, do a partial update on that document. Nice thing about that is that it reduces the payload, so that's going to reduce the number of resources that's consumed on the client, your client, the one that's running our SDK. The other thing is it's got some other really kind of cool features to it as well. But on the server side, it's not really going to save you a ton of money or a ton of throughput or RU on there. So I just want to point that out. So, okay, so here's our first entity. We've got one-to-one relationships in here, and we've got one-to-few relationships in here. So we're going to embed everything into a single document. Okay, so we've got our first entity. Now, when you create a container in Cosmos DB, it asks you for something called a partition key. Well, what's a partition key? Well, remember earlier when I said that Cosmos DB basically provides this abstraction over containers or partitions within your data across these kind of physical servers that it's storing its data on, right? So when you're storing documents in Cosmos, you have to, they get written to these different physical servers, right? And you may be thinking, well, how do I control where my document is getting written to if I don't have a single database that I'm writing to all these different ones? Now, that's actually something you don't need to care about. What we have within Cosmos DB is this notion of logical partitions. So think of it this way. The piece of compute that you get and keep adding on to, we call internally a partition, right? It's really a little slice of computer, a little VM within there. With our design within Cosmos, we've implemented this kind of layer over that we call a logical partition. And the idea there is to provide kind of the same feel for that, or just, how do I put this? How do I get this? All right, let me put it this way. Within Cosmos, we run on multiple generations of hardware. Some of it has less storage than others. To provide kind of a uniformity to that data, we define this thing called a logical partition. And the size of that, well, I'll talk about the size of that there. But really what I want to say is you don't need to care about logical partition. Well, you do need to care about logical partitions, but you need to care about where your data is physically stored within there, right? You're going to use this thing called a partition key. And partition key is going to be a property within your data, right? It's something that should be innate to the data that you're storing within there. So here I've got a partition key of username. So within the logical partitions I've got here, I'm going to have a logical partition with username Andrew, and another one with username Deborah and Tim and Mark and Luis and Theo. And those, that's going to control, if you will, how your data is written into Cosmos within there. Okay, so there's two things I want to point out here. One, there's some constraints that you need to keep in mind when you're modeling your data in Cosmos. First is the maximum size of a document within Cosmos is 2 megabytes. Now, remember earlier when I said you want to avoid unbounded arrays when you're modeling your data? This is primarily the reason, is you're going to end up hitting this 2 megabyte limit. The other thing I want to point out too is that as you increase the size of your documents within Cosmos, the cost of the RU, or the throughput necessary to process it, doesn't grow linearly with the amount of storage in the document. It actually grows at a faster rate. So the bigger the document, the more expensive it's going to cost. In some cases, once you start getting out about like the 500K range, it may be actually cheaper to shred the document into 2. Right? Now, that'll help in a couple of ways. One, if you do updates, you don't have to shuck the whole payload back, right? So that'll help with that. But just on a per operation basis, for that same set of data, it may be less expensive for you to shred that document. And also avoid unbounded arrays. And then the second limitation I want to point out is for a logical partition, that maximum size is 20 gigabytes, okay? So you need to make sure that when you're designing a partition strategy around your data, right? So all of my data in each of these logical partitions is going to be probably stored on different physical servers. You need to make sure that you've got high enough cardinality with that partition key that you don't blow up that 20 gig storage limit within there, okay? All right. Now, when you provision a container in Cosmos, you're going to pick that partition key. You're also going to select the amount of throughput that you want on that container. That throughput controls, if you will, how many physical partitions, how many of those different physical servers we're going to provision for you in the back end. And when we do that, the throughput, right, that essentially that's the kind of the compute necessary to run that partition, is spread evenly across all of them. Now, there's some implications for this. First, you want to make sure that you design a partition strategy that's going to spread your data evenly from a storage perspective. If you don't, let's just go back to the example of like username. Like say Andrew is really, really popular, and I don't know, he's got lots of documents in his logical partition, and the other people are not so popular in there. You're gonna end up with a scenario like this, where you've got one logical partition that's got all the data in it, and others with very little, right? And this is what we call canonically kind of a hot partition within there. And this is definitely something you really want to avoid. For all the reasons I just stated earlier. Same thing goes for requests as well. Take the storage aside, but if say Andrew or Mark has lots of requests going to it, then you end up kind of a similar issue there where you end up kind of with this hot partition that's going on there. Now you may ask, like, why do I care about this? Or why would it matter, particularly from a request perspective? And keep in mind that this throughput that you provision for that container, you're paying for, right? It's like a VM, right? You wouldn't provision like a ginormous VM and play solitaire on the thing, right? Because that's a waste of money, right? And you want to be efficient in how much resources you're going to provision for your account or for your container within Cosmos. So if you've got a hot partition from the number of requests that are going on within there, you're not utilizing, first of all the throughput that you've provisioned, right? It's just not there. You're only getting a slice of that because you've got multiple physical partitions in the background. More worrisome is that you have partitions that you're paying for, but you're not using, right? Again, it comes back to the access patterns that I talked about earlier, right? Understanding those access patterns, particularly those that have high concurrency, is going to matter, right? And that comes together with the storage on that. Now, how do I describe this? I mean, let me go through a slide because I'm kind of riffing, if you will, on this. So I talked about the hot partition for the storage and for the throughput on there. I had one more point I was going to make to you guys. It'll come to me. So, long story short, this is what you want to see from both a storage perspective and a request perspective within there. It goes back to the access patterns. Like, the thing that matters in how you get to something like this is having a really solid understanding of the access patterns for your app. Now, what does that mean? That means I need to know all of the operations that are going in. That means I need to know how users get into that part of the application. That means maybe I need to talk to guys like my UX designer and others who are working on designing and building this application or service so that I can understand fundamentally, how is this app going to behave? If I click on this, how many things go on in the background? Now, if I multiply that by X number of users, how many times does that happen in the background? What's the likelihood that I'm going to get that number of users? You have to even go through a capacity planning type of exercise when you're thinking about designing these types of things. It's a lot to take in, and it's a heavy burden early on when you're designing an application or a database with Cosmos. But to get to a point where you can achieve kind of this infinite scale, these are the types of considerations that actually matter a lot when you're designing a database like Cosmos. Another thing I'll say too is don't be afraid to iterate. This happens over and over and over again. I see customers, they go in, and they may understand all of these things, right? And understand their workloads and the behaviors of these things. But you know what happens with apps that you design and you put into production? Is customers sometimes use them in ways you didn't realize, right? And the assumptions you had early on are gonna be like, oh, I didn't see that coming, and you're gonna have to redesign. And so being comfortable with iterating on your design over time, particularly through the development stage, but even into production, there may be needs where you need to go and make changes and migrate your data into a new container with a better partition key. One more thing I want to say. In a write-heavy scenario, when you're designing your application, the thing you want to do is you want to distribute those writes across all of those partitions as much as possible, right? Because what do you want to avoid? You want to avoid this that's going on. So say I'm in like an IoT scenario or something like that. What would be a good partition key? Was date a good partition key? Who thinks date is a great partition key for any scenario in a write-heavy workload? Good. Who thinks it's a bad idea? Yeah, why is that? Come on, you get a coaster. Why is date a bad partition key in write-heavy scenarios? That's correct, because today is always hot, right? Always. You cannot get away from it. you've got to use something else. Something maybe like device ID is good, right? Because it's going to be unique across all the devices, and presumably all your devices are sending or emitting data at the same rate, right? That will get you back to something being smooth. Now, let me go and talk about reads, because another thing you need to solve for in applications is reading data, right? So if I have my whatever collection here, and I'm using username as my partition key, if I have a high concurrency query like this one here, where I'm going to select star where C equals username Mark, and what's going on with my thing? Uh-oh, battery dead. All right, here we go. Oh no, what's going on? There we go. Yeah, sure. Here, my username is my partition key, right? And that, oh, now it's working again. So that's good, right? Because Cosmos knows exactly where to route my query, right? That's efficient in terms of design, especially for high concurrency queries, right? What if I have a query like this? What do you think happens to that query? That's right, it doesn't know where to go. So what does it do? It dispatches to all the partitions. And this is something what we call a fan-out query or a cross-partition query. You can have cross-partition that's not fan-out, but you can have true fan-out where nothing in your query is going to help it find the data that's in there. So what does it do? It dispatches to all of your partitions, and it's going to search for all of them. And this is very expensive because each of those is going to consume throughput on each of those partitions. It then needs to take that data and then put it back together and then ship it back to you, right? So these are very expensive. You want to avoid these things at all cost. Okay, hold on. Last thing I want to say. So you understand, right, designing for the read heavy, what do I want to do? My objective is to make sure that for high concurrency queries, my data is sitting on a single partition, right? But what if I have an IoT scenario like I just said? Because I just said the opposite before, right? What was my objective there? I wanted to spread it out, right? And now I'm saying, no, you want to keep it together, right, for the read-heavy workload. Well, what if I have both? Does that ever happen, where I have to write a bunch of data and then I have high concurrency reads? Yep, it sure does, right? In lots of applications. In an IoT scenario, where I'm partitioning by, say, device ID, there's no way that I'm doing high concurrency queries on a device. It just doesn't really happen. I'm probably going to look at it by, I don't know, depends on the scenario, maybe a building ID or my floor or by customer or something. It's not going to be the device. It's going to be some other value, some other property within there. So how do I solve for that, right? Mark, you're telling me that I need high concurrency for writes, but I need this for reads. The answer is just create another container, right? We don't care about duplicating data. And in this scenario where you've got high concurrency writes, very high volume of writes with high volume reads, you need to solve for both, right? And since we don't care about storage, we're gonna use, well, something called change feed, and I'll show you that in a few minutes. And we're gonna copy that data. So everything that's written or updated into my first container where I'm ingesting all that IoT data, I'm gonna then copy into a new container, and I'm gonna give it a new partition key, whether it's name or building or something within there. Okay. That's a lot of heavy concepts. You guys okay? Everybody all right? I'm gonna show some code. I thought this was gonna be a code-free day until the last session, and then I got beaten to it. But the rest of the session, I'm gonna go through, I'm gonna model AdventureWorks. I'll show you some, and then I'm gonna do lots of demos. So this is gonna go back and forth really fast, okay? I'm gonna show you some code, I'm gonna show you our SDK, and I'm gonna go through and I'm gonna model this data and I'm gonna show you how it works, okay? So we just learned a whole bunch about partitioning within Cosmos and design stuff within Cosmos, and hopefully that's all sticking to you. What are we gonna do for here for a partition key? Well, let's look at our access patterns, right? This always comes back to the access patterns. I gotta create a customer, I need to edit a customer, and I need to retrieve a customer. Which of these three operations do you think happens with highest concurrency? Retrieve. And how am I likely gonna wanna retrieve the customer? Let's say I'm logging in. What am I gonna use? like a username or an ID or something that's going to be unique, right, within there. So I'm going to call it ID here. It could be anything, but it has to be something that's unique within there, right? So I'm going to use ID as my partition key for my customer container here, okay? Now what that does is that fundamentally creates a logical partition for every single customer within that container, right? Remember the logical partitions, those are the things that your data goes into and you get 20 gigs of storage, right? Well here, I'm gonna have logical partition for every customer, but it's only gonna have a single document in there. Now I sometimes hear, hey, is that okay? Can I have like 1 million or 1 billion logical partitions within a container? And the answer is yes, right? It's just a logical construct, these things like logical partitions. It doesn't change or matter really in any way from a performance standpoint. The way you can think about using something like ID as a partition key is that it fundamentally turns the container into a key value store, right? Because really the only thing you can do in that sense is just, if you want to do an in-partition read, is just do a read in there and use the partition key as the ID and then pass both ID and partition key when you're reading your data within Cosmos. Otherwise, if you ran a query in there, what's going to happen? Cross-partition, right? And that's something you want to avoid. One other thing I want to talk about too before I get to a demo is don't feel like when you go and you design a database in Cosmos and you do all this testing and stuff like that and you're like, oh, these queries are great, they're fine, they're fine, they're fine. That doesn't mean anything in Cosmos. If you want to design for scale, guess what? You got to scale it first and then test it and see how it works. So you've got to load test these things using tools like Bogus and others that you can use to ingest tons and tons of data, put load under the thing, and then measure, right? You've got to get it out to a point where where it needs to scale, and then measure the performance that's going to happen within there. If you create a database and you're, let's say, less than 50 gig, because that's the maximum size of a physical partition, the data that you get back is going to be meaningless. You need to scale that thing out to a greater extent. Then load test and measure, and then you can tell. Did I make a good design? Okay, so let's do some demos. How do you guys feel about that? No? You guys don't care about demos? All right. What's wrong with my mouse now? Are you looking at the right thing? Okay, good. So I've got, I've got my Cosmos account here, and I have 4 databases in here, and each of these represents kind of a different iteration as I go through and I model my data in here. So my first one, V1, I've got all the different entities, all 9 of them, that came straight over from AdventureWorks. I've got customer, address, password, product, blah, 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 okay? And as I go through, I've got another one here with customer, and you can see I'm missing customer address and customer password. Why? Because I've modeled it within my customer container. So to understand why modeling data this way matters from a performance perspective and from a cost perspective, let's take the original, the V1 here, and run some queries if I want to go and fetch a customer as they come in. So here I've got a query, select star from C, where CID equals this customer ID that I'm going to use for the rest of this demo. And here you can see I've got data within here. Here's a customer and partitioned by ID. And you can see, whoops, first name, last name, email, address, phone number, all that stuff that I showed you earlier, okay? So let's run the 3 queries we would need to run to get our customer. So I've got this one here. I need to run this. And that's, yeah, fine. Query stats. How much did this thing cost me? 2.83 RU. Okay. Let's go do the second one. So this one is going to go and grab address data right here. So let's run this guy. Execute. And what happened? Where's my... There we go. And this one, that's more expensive. That's 11 RU. So we're like 14 RU for those 2 queries. I got one more. I got to get my password. Yep. And that one, about 3 RU. So 14, another 3 on there, about 17 RU for that one query, right? Not only that, but I had to dispatch 3 different queries over the WAN 3 different times, right? So that adds latency and cost. Now, let's look at it. Here's my V2. Here's my customer within here. All right, and I've modeled all this together. So I've got my customer in here. Here's my address within there. And then there's my password within there. So let's run a query on customer here. Portal, there you go. And I've got my customer in here that came back. More importantly, the cost of that query is just that 3RU, right? So order of magnitude less expensive, plus one operation, not three, right? Because we're optimizing for compute here, right? Okay, so that's the portal. Let me show you how you do this in Visual Studio. So I've got a little app running here. That's this one here. I'm going to run some demos, and I'll show you the code that we've got in here as well. So here's how you do a query within there. So I need to get a reference to my database and my container. So there's my customer container. Oh, and that's going to, yeah, V2. And there's my customer ID that I use in my query. Here's a little query. This should not be too weird or different for you to look at. I'm going to create this get item query iterator, send it a query definition, a parameter, and then request options. I want to pass my partition key. Super important every single time. Pass the partition key in your query. If you don't, guess what? Cross-partition query. One caveat, you can not include it, but if it's in the where statement, we'll sniff that out and still run that in the partitions that you have within there. But as a best practice, I like to put it in there because it better documents the code that I've got in there. Okay, so I'm going to run this query, and then I'm going to iterate through it, and I'll print out the request charge in there. So I'm going to run number A there. Here's my customer. Quote for a single customer coming back here. Destiny Peterson, there's the address, there's her password, and there's my request charge, right? The 2.83 that I showed in the portal, right? So that's okay. One thing that a lot of people don't realize is that if you are using ID as your partition key, you can also use this other operation we call a point read, right? You can also do this when you're looking for other data, provided you know the partition key value and the ID for the data you're looking for. And let me show you that, because this is quite efficient as well. So here's my same customer ID, and I'm going to call this function called read item async. I'm going to deserialize that into my customer object here, and then I'm going to pass my customer ID, right, which is the ID, and then for my partition key, pass that same value, okay? And then I'm going to print that out and the request charge. So remember before, how many RU did we have for that query for a single record? It was 3 RU. Let's try a point read and see what happens. So there's my same data, but my request charge is just 1 RU, right? So I've gone from 17 RU down to a single RU by modeling my data in a way that's efficient for a NoSQL database, and then also this operation where I'm just looking up a single record. If I know the ID and the partition key, I can get it this way, right? This is the most efficient operation you can run in Cosmos, is a point read within there. And where you have high concurrency operations, I would strongly push towards being able to do point reads on that data because it is so efficient. Okay, let's go back to slides. This thing, I think it's working again. Okay, next up, let's work on products. First, I got product category. I'm going to do the same thing I did with customers. I need to, translate that into JSON. Within there, I'm going to put that in its own container. I'm going to call that product category. But I have to pick a partition key for that thing. How am I going to do that? I'm going to look at the operations again. I'm going to need to create a product category. I need to edit a product category. And I need to list all product categories. So what do you think is going to be the high concurrency operation out of all of these for product category? It's going to be list, right? Well, I can do a select star from C out of this container and get all my product categories. And that's probably going to be efficient. Actually, in fact, I know it is, right? Because there's not much data in terms of product categories within there. But I'm going to do something a little different here. And this may look weird to you at first as I go through this, but believe me, there's a reason why, and it's actually something you'll think that's very cool when you're done. I want to make this an in-partition query, okay? So I'm going to add a new property to this container, and I'm going to call it type. And I'm going to give it a constant value, and I'm going to call it category, okay? Whoops. And now, when I run queries on this container, they will be efficient always, no matter how many, well, that's not true. It'll be efficient for product categories within this use case, and the reason is you'll see why later. So let me do another quick demo on product categories. So list all product categories. I've got my product category container, select star from C, where C equals category, create my partition key, passing in that static value string category, and then I'm going to iterate through all that and show you the request charge within there. Okay, so list all product categories. Whoops. Oh, I just put a C in my code, which made Visual Studio very mad. Okay. Oops, there we go. So categories coming out here. Got the ID, the name, and then the type, obviously, coming within there. Okay, and then request charge. Where is it? Man, a lot of categories. About 4 RU. So that's not bad. But honestly, without a partition key, that'd be okay, too. However, you need to define a partition key for your container. In this case, I'm going to use this type thing, put a category in there, and then use that. And that'll keep it in partition. But the real reason why you're going to care about that, I'm going to show you in a little bit, okay? Just trust me. Okay. Next, let's do product tag here. So same process. I'm going to put that into a JSON, create a product tag container, and look at my operations, create and edit. I'm going to list all product tags. It's going to be my high concurrency. And I'm going to apply that same technique I used earlier. And I'm going to create a type property, and I'm going to give it a constant value of tag within there. Okay. Next up, let's look at product within here. So I want to look at the relationship I've got between product and product tags. Remember, we've got a many-to-many relationship that's going on with here. And I need to access the product tags, meaning I want to display them when my products appear on that page. So I need to be able to query that in a high efficiency way and return back my product tags with the product that's within there. Now, I could do this in kind of one of two ways. I could store the product info in my product tags container, or I could materialize those tags and denormalize it within my product container. So that's what we're going to do. Because there's fewer tags per product than there are product per tags, it makes more sense to materialize that, right? I'm denormalizing, materializing that data into my product container here. And remember, there's a one-to-few relationship, right, between product and tags, right? It's not an unbounded relationship. So I'm okay embedding tags into my product container here, right? This is a good candidate for embedding. So this is going to be the structure of my new product container here. So I'm going to have products that I showed earlier, and then I'm going to have an array of tag IDs as well. So we next need to figure out a good partition key. So I want to create and edit a product, but those are low concurrency operations. The one I'm going to be running the most is going to be listing all products from a category with the name of the category and the tags. So we need to run these queries here. I need to select star from C, where C category equals category A. And then what you're going to have is within every category, you're going to have all the products within that category there. So that's good. That's going to be when I click on the product category, single partition query, high efficiency, all good within there. So what do I do about the category name and the tag names, right? Because I want to display those within them, but they're sitting in their own container. All I've got is the IDs within here. Well, I have to run a bunch of queries to get that, right? So I want to first run a query against my product container, right? So I want to get all the products for category A. I need to then go get the name of the category, right? So I then got to go run another query on my product category container. And then I'm going to have multiple products come back, and each of those is going to have its own set of tags associated with it. So depending on how many products I get back, I'm going to have to run subsequent queries to go get all the product tags for all the products. Now, you may be saying, hey, just join the thing. But we don't do joins, right? We don't do distributed transactions, potentially where you would have data in different containers or in different partitions sitting on different physical pieces of compute, right? So what am I going to do? Well, I'm going to denormalize that data, right? Again, I'm going to embed the name of the category and the name of the tags within the table, or within the, the container itself. This is going to help reduce the number of round trips that I've got to make, particularly if I don't know how many I got to. If I got to iterate through a result set to go run more operations, that's a bad idea, right? Just no matter what, if you're using this type of database or not, it's a bad idea. You want to model your data so that it's ready to go as the user needs it within your database. So we're going to denormalize and then optimize our data for that. So here I've got my new product category, or my new product container, product category ID, right? Because that's how I'm looking them up. And within there, I've got my category name now embedded within there, and then the tag for each of the tags that's within the array there. So by doing this, we make sure that basically we can retrieve all the data for that category in just a single request. Okay? So let's show you how that looks. How am I doing on time, by the way? Are you serious? Holy crap, we're going to forget that demo. I'm going to keep going here. All right. It's an awesome demo. I'm kidding. It's not. It's just a demo. I'm going to show you all the product categories. So this is great. So now, what happens, though, when I change a category name, right? I've got to reflect that and keep that in sync with my product container, right? I've created a problem here, right? And I know as a SQL developer, when you denormalize your data, you always create this secondary headache, which is, oh my God, I changed something in my master data. Now I've got to go and ripple that through everything else. So how do I do that in Cosmos? Well, turns out we've got an ideal way of doing this, and it's called change feed. And change feed is basically kind of an API that's exposed by the Cosmos DB containers. You access it through our SDK, through the container resource that's within there. You listen to the container fundamentally, and then as changes happen, they're basically sent to a delegate, and then from that delegate, you can go and do something with the data that's within there. Whoops, did I miss something there? No, okay. So in our case, we're going to listen to changes that happen to the product category container and also product tags. And when those changes happen, we're going to catch it, we're going to replicate or update our product container within there, and then everything's going to be in sync. So let me show you this demo. This one's definitely more interesting. And here we go. So I'm going to update my product category name within here. So here's update category. So I'm going to grab a category. This is accessories, tires, and tubes. Now I'm going to do something trivial here, and I'm going to replace the and in that category name with an ampersand. Okay? So I'm defining a new product category type here, just passing in the category ID, and category is a static name. And then here's my new name, accessories, tires, ampersand, tubes. And then I'm going to call this function replace item async. This is another point operation. I'm going to take a partition key and an ID, and then I'm going to pass the new product category to that there. The second thing I want to show you is change feed. Oh, God, whatever. Within change feed, this is implemented in a very simple way. I'm going to, change feed processor builder off my product category container within there, and then this is my delegate is input, and I'm going to deserialize that as a product category type within there. So this thing runs and polls about every second. You can change that polling interval if you want, but that's what it runs by default. And then as new changes come in, it'll have multiples if there's multiples in there, right? Because this is an I read-only collection, so it's an enumerable collection that's coming in. And then as that happens, my code here is going to iterate through all those changes, and then it's going to call update product category name with my category ID and my new category name. So let me show you that. That's just a little further below. Here's my update product category name. And so I need to do a couple things here. I need to query for all products in that category, right? So select star from C where category ID equals that. Pass my partition key. And then I'm going to loop through all of those products. And I'm going to change the category name to my new category name in there, and then call replace item async on each of the products within there. Okay? So there's all our code. Let's go and run it. So I'm going to update product category name. So I've got print out the number of products. So I've got 11 products that are accessories, tires, and tubes. Let's update it. Now watch below. One change received. And I'll update it to ampersand in there. Let's go back. And I'm going to print out the category in there. I've got 11 products that are accessories, tires, ampersand, tubes. Okay? In fact, I'll change this back in case that was too fast below. There it is, one change received. And it's updated. Now back to normal. It's in there. Okay? Is that cool? Did you like that? Okay, I got more. I'm done now, aren't I? It's top of the hour. Are you gonna let me go a little bit longer? 4? All right, let's do sales orders. Right, make them into JSON. I'm gonna embed my details into that because that's good to embed it. That stuff gets access together, right? I need a partition key here. What's my operations? Create a sales order, list all sales orders, and query top 10 customers by sales order. Well, I'm going to make this really easy. This one is going to be our high concurrency operation, or at least the highest in this scenario here. So I'm going to use my customer ID as my partition key. And so every customer, all of their orders are going to be within a single logical partition within there. So that's going to be my partition key. Now, let's take a step back. Notice we have another container that has the same partition key, and that's the customer container. So could we mix those entities in the same container? Who thinks yes? Yeah, good, I'll give you all coasters. Yes, you absolutely can mix them all in the same containers. This is actually a benefit, a strength of a database like Cosmos. Cosmos doesn't enforce a schema, right? In a relational database, you gotta define your schema, right? Create table, blah, 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 right? Not necessary. That's all managed within your application. Your POCOs define your schema within there. And this is actually a best practice. When data shares similar access patterns, customer and their sales are generally accessed together, and they share the same partition key. In this case, it's customer ID. So I'm gonna make some more changes here to my design, and I'm gonna put both customers and their orders within the customer container. I'm gonna now add customer ID to my customer entity. And then I'm gonna add a new property, my type property. That thing's coming back. And I'm gonna call sales orders are gonna have a sales order constant in there, and customer is gonna have customer constant, because I may wanna query them separately within there, right? And so now for every customer that I've got within here, I've got a customer and a sales order, all their sales orders within there, right? And so here's my query. So select star from C, where C customer ID equals customer A, and C type equals sales order. So now I can get all their sales order back in partition within there. Okay, I'm gonna try and get through the last of these. I'm sorry, this is going so long. I'm gonna create a new customer and I'm gonna update their order total. The last thing I'm gonna show you is transactions in here and denormalizing. In fact, let me show you this and then I can do it all one big demo. So last thing I wanna show you is this here. So my last thing, query number, top 10 customers by number of sales orders. This is actually a query that I can't run in Cosmos with this container that I've got. What I need to do is another technique, and that's called materializing aggregates. So in this case, I'm gonna take sales order count, and I'm gonna embed that as a new property within my customer record. And every time I create a new customer or a new sales order within here, I'm gonna increment this amount and materialize it, save it back into my customer record here, okay? So, yeah, so that's add a sales order, update the customer. Okay, so let me show you, where are we? Create new order and update, create new customer and update total. So I'm gonna get my customer ID here, that's my point read, right? Read item async within there. And then I'm gonna do customer sales order plus plus, okay? So I'm gonna increment within there. And now I'm gonna create a new sales order, and then I'm gonna use this really cool feature called transactional batch. This is one of my favorite features in our SDK. But Cosmos, yeah, we're not relational, but we support transactions. The difference is that the transaction is scoped to, you guess it, a partition, a logical partition in this sense. And why do we do that? Because it all runs on the same machine. It's not a distributed transaction. I don't have to worry about locks on data. It's fast, right? And you're gonna have predictable performance. So this is what we're going to use, is this transactional batch. And then we're going to create a new item. That's our sales order. And then we're going to call replace on our customer with the updated sales order total. OK, so create a new order. Let's query for a customer and all their orders here first. We'll go pick on a single customer here. OK, so this customer got 2 orders. All right, so here's my customer, Destiny Peterson, again, the same one. And she's got 2 sales order. And I've got the customer record and both sales orders within here. By the way, one more thing I want to show you is how do I query for stuff when I've got multiple entities in the same container and I want to deserialize the thing? That's actually not too hard to do. Instead of deserializing data directly into a POCO, into a type, deserialize it into a dynamic type, and then as you iterate through the data, inspect the type property. Ooh, that's a customer. I'm going to deserialize that into my customer object. Ooh, that's a sales order. Deserialize that into that. Okay? Just wanted to show you. Okay, let's get back to here. Sorry, I'm so late. Create a new order. Create successful. Now I'm going to query that customer, and I'm going to show new order, and where is it? Sales order count is 3 now. Okay? All right. My very last slide. Sorry. Let me get to the model here. All right, you want the payoff? So, final design. 9 tables down to 4 containers here, but I can go one further. I can actually take the product category and product tags and make that into a single container. Because guess what? They share the same partition key, right? This is an excellent way of optimizing for storage cost in Cosmos. If you have like master data that's just looked up and referenced, or say things that hydrate your UI, stick them in a single container called meta or something like that, and then give them a type property so you can distinguish these things. You can quickly, easily query these things. And then if it's in a single container, you need one change feed instance, and you can manage your referential integrity to anywhere else in your database. Okay? That's it. So I went from 9 tables down to 3 containers. This thing is built to scale. Go anywhere. Key takeaways, I hope you got it. Here's a bunch of cool stuff. Thank you very much. Appreciate it. It's hard to stay within an hour, man, when I riff.
No, that was fine. No worries, man. Hey, we're going to have a 10-minute break.
Coaster.
What's happening to the stream now for the people on the other side of the camera? This is, oh yeah, you just throw those coasters to everybody. That's nice. You can continue doing that while we are closing the stream here. So thank you for the audience in the stream. Here live we'll have a panel, and then we'll have food and drink. So we hope that you get food and drink at home too, or at work. Thank you for you there, and let's continue tomorrow. And here, 10-minute break. Let's come back 20 past. And thank you to Mark.